It takes place an afternoon in November, and it lasts 6 hours. The students have access to a problem that is given to them. That is, the problem is given by an industrial sponsor, and they have 6 hours to solve that problem. So this is typically, it's an operation research problem. The problem consists in optimizing an industrial process. Typically, for instance, the first hackathon, the sponsor was Air France, and the purpose of the hackathon was to build the sequence of flights done by the airplane at Air France. And every year we have a new sponsor and new topics. And so the students have access to instances with all the data of the problem, and they must provide a solution. They upload this solution on a website, and their solution is evaluated. So typically on the Air France example, what you would have is you evaluate the cost of doing these sequences of flights with the airplanes, and the team that gets the best solution wins. And to make it a bit more fun for the students, so all the students are in the same building during that hackathon, and you have on the big screen the current ranking with the best solution that is updated all the time, except in the last 30 minutes, so that there is a little bit of suspense on who is going to win the hackathon. The initial idea of this hackathon came from the students, because they noted that we have an operation, it's alongside an operations research course, but at the beginning it had nothing in common. It's just that some students of the operation research course noted that the course project looked like a Google hashcode, and they wanted to organize a competition for the team of students of universities from Paris and France. And so they came to see the academics and asked us if we could help them organize that. The good thing with it is that it's the students that organize the event. I mean, all the logistic, the buffet, the relation with the sponsor, the communication, the website, everything is done by the students. The role of the academic is just to find the sponsor and write the subject so that it's fun. Actually, so the first hackathon was completely disjoined from the course, but we had already some feedbacks on it. The first thing, the students understood the relevance of the course tools, and so they were much more motivated for the course after the hackathon than before, because they had seen that these tools can immediately be applied to real-life industrial problems. They so that they effectively solved it. They found the experience fun, and so all this made the course more attractive, because also the hackathon was open to all the students, and notably younger students of the university who could follow the hackathon the next year. But the negative aspect of having it separated from the operation research course was that only the most motivated students participate, and 6 hours, so the time of the hackathon is very short, and so they didn't have time to develop advanced techniques, and basically it was the more geek student that won with a very simple algorithm, which was not the objective of an operation research course, for instance, where we want to have some more advanced algorithms. So the second idea that came was that, we should schedule this hackathon within the operation research course and use the topic of the hackathon as the topic of the project course, to give the students several months after the hackathon to work on the project, because it's provided by an industrial, it's a real life case, and so it's interesting. And so what we ended up is with this kind of organization. So now there is two parts in the operations research course. A first part where we introduce the mathematical tools, and a second part where we see the applications. So now we schedule the hackathon just in between the two parts at a moment when all the students already have the tools that will be needed to solve it. Then there is the hackathon. It's not mandatory. It's just the students who want to participate to the hackathon participate. It's the student event, but we take the subject of the hackathon and make it the subject of the project course. And then they have 2 months to develop advanced solutions to solve the industrial problem that is considered. Often, the industrial sponsors invite the best team from the project course to give a presentation in their firm, and they often give another prize at that moment because they are generally very happy with, very impressed by the solution, the quality of the solutions produced by the students. And for the project evaluation, 1/5 of the grade comes from a ranking of the students' solutions, and we maintain this system where at all times they have access to the score of the best solution of every team. This because it was a constant feedback that the students found it more fun if there was some sort of competition along the project. They were more motivated. And so the feedbacks now on this new version of the hackathon. The first thing we have observed is a steep increase in the quality of the students' projects. I mean, because of the hackathon and because of the industrial sponsor and because it's a real life project, students are really much more motivated, and the quality of the projects was really impressive. And not only on the project, but on the on the course as a whole. And I mean, the grade at the exam are better now that we have the hackathon than they were before, because the students have worked a lot on the hackathon and have better assimilated the concept of the course. Around 25% of the students are super excited with the hackathon, works a lot on it, and many of them will start their career in that domain, or in more generally in computer science or mathematics, because they really enjoyed this kind of work. The 60%, an additional 60% are very happy with the experience, even if they are not going to specialize in the topic. But around 10 to 15% of the students, which are generally the weakest one, find that it's a lot of work and some pressure, and so even a negative experience to the hackathon. But that's generally the students who do not like the operations research course, whether there is a hackathon or not. Another thing is that every year sponsors are really impressed by the quality of the solutions that the students managed to do. And something we did not think about, and that happened, is that employers really love it. And in the sense that several firms that have operations research teams in Paris, since the subject of the hackathon are public, actually do the hackathon by themselves on their side. And when they meet the students, they ask them, well, what did you do on the hackathon? How good were you? And things like that. And there is even a firm where you get a 10% bonus when you sign if you have been well ranked in the hackathon. But the reason why they like it, it's because, it looks like what the students are going to do in real life is if they start a career in operations research or more generally in this kind of data science firms. And so actually, as a person, when searching for the first job, the student can see that they have something a story to tell if they have participated to this hackathon and they have done a good job on the project course. And finally, if there is some feedbacks to give to people who would like to organize such as the hackathon next to course, the main feedback would be, don't underestimate the time you will need to organize it. First, finding the sponsor is not complicated, but and we do not want to be involved in the organization of the event. I mean the 6-hour event, because it's the thing of the students and it takes time, and there is no need for us there. But several things take a lot of time. The subject first, and it highly depends on the scientific maturity of the sponsor. If the sponsor is very mature, it goes very fast. If they give a subject that is nearly perfect, and there is almost nothing to do for the academic. But it's definitely not the case of all the sponsors. The second thing is that because you need a product that is fun and challenging, you need to be all the students need to be able to find quickly a good solution, because otherwise it's not fun. But it needs to be extremely difficult to find an excellent one, so that there is a competition. And making a project that satisfies these two conditions is quite complicated. Also, since there is this, it's a competition at the beginning, the project must be cheat-proof, and this takes some time. And finally, the evaluation of all these projects can take some time, because I mean, there is some engineering to be able to automatically evaluate the solutions, and we have to correct all the things. So compared to a purely academic project on a toy problem, we clearly doubled or to triple the investment needed by the professors. So thank you very much, and if you want some more information, just you can go on the website of the hackathon. The website is in French, but the most recent subjects are in English, and so you will be able to find complete examples of well, how it looks like. Thank you.
So let's thank Axel. Again, I guess the questions are at the end of the session, right? So I guess we should proceed with the next speaker. Is that online as well? No. She's here. Okay. So it's.
Yes, thank you. Is it a... Okay. So my name is Mariana Mocano. I am coming from Bucharest Technical University, and I am a professor basically in computer science. I would like, first of all, to give you some ideas about the university. Maybe not everybody heard about it. And then to give you an example of blending research in a typical course in master studies. So my university is not so old like E2, but still we celebrated 200 years. And in these 200 history years, we had several improvements. We changed, we adapted to what the market is asking. And now we are offering studies on bachelor, master, and PhD level in 15 engineering faculties and 2 additional departments. We have an UNESCO department and a department specialized in preparing future educators in engineering, teachers in engineering. So we have lots of projects, and we are very proud of our communication infrastructure. Basically, the university is in the is a regional node for the entire European research and education network, and it is managed in our university for the entire country and for our neighbors. Of course, this use of the IT infrastructures started years ago. Here is just an image of our data center. What's our preoccupation now, and you will hear about it more from some colleagues who have also some presentations, is the idea to interconnect what we have There are lots of platforms. We see every day it's appearing something new that we have to handle, to learn how to use it, and so that we offer to the students support not only for everyday learning, teaching, but also access to libraries, access to administrative services, and so on. In this landscape, there are offered 181 master programs in 19 fields. Some of them are deep specializations, but many are now interdisciplinary because it's something that's demanded on the market field. And of course, we have also several teaching programs, master programs. All these kinds are specified in our education law and have to correspond to the type of the university. We decided at the level of the university that we focus on research programs, master programs. And what does it mean? It means that they last 4 semesters. There are 120 ECTS offered, and there are 20 hours a week, but not all are direct teaching. You will see it. Of course, we want to give the students the best possibilities to work in common Europe or common world. So we offer programs not only in Romanian language, but also in English, French, and German language. And the master studies in general are organized in the first semester, having 16 hours of teaching activities, and 12 hours are dedicated for research. In the fourth semester, 28 ECTS are dedicated to research, preparing the dissertation thesis, and also to internships, but that has to be related with the research activity. And we have additional course in the last semester, ethics. This course was introduced in all master programs in Romania according to a governmental decision, I think 4 years ago, something like that. We have, of course, courses, general courses, but we are very proud to say we try to give the students what they want. So we have elective courses. That means they have to choose, they are obliged to choose from a pool of other courses. Some of them are taught at other master programs, and some of them are offered generally that they can choose one of these. And of course, according to our law, education law, they have also the possibility to change one of the obligatory courses with other ones from even other faculties or universities, if they want to do it. And of course, in this context, there is a rule for recognizing the credits that are acquired by the students. We have many students that benefit from Erasmus projects, but there are also other mobility programs. Now, coming to the research, each student has assigned a tutor. It's one of the teaching, a person from the teaching staff, and at the beginning of the first year, the students choose, assisted by the tutor, a topic. The topic must be related to the master studies profile, and then they have to perform a normal research activity in the first semester, state of the art, then to plan the entire application, and so on, to go through all the steps of a research. every semester they have to write a report and present it public in front of a commission. And in the end, there is also, of course, the dissertation. It's mandatory that they achieve the 120 ECTS before attending to the dissertation. And there are also other helping activities. For instance, every year we organize a symposium for research, presentation of researches of the students within their studies. And of course, some of them are also involved in research projects that are led by professors, national or international projects. Now going a little bit deeper, I give you the example of a master program. I am in charge of this one. It's called EGovernment. And as you see, it has the general structure of all our master programs. We have optional disciplines. We have this research in the first 2 semesters. And then in the third and the fourth semester, it's going on as I just said. One of the courses is called Decision Support System, and here research has an important part because we have the theoretical input and then the the practical one in form of a project. For the theoretical input, it's not only based on lectures of the teacher, but the students have to prepare on very precise topics, a short presentation, and then during the lecture hours, and then there are general debates in order to see that everybody has understood the specific topic. So they have to read themselves and to try to understand and make also the others understand what they have learned. The project activity is based on a topic that's related to e-government. For instance, the topic of this year is to design an IT support for a modern kindergarten. And they have to learn that it's not only preparing maybe some slides or some to play, some support for the children to play, but they have to understand that in a kindergarten there are also administrative operations, or for instance they have to deal with ensuring the security on the campus, to prepare lunch for the kids and to make the suppliers to supply it and so on, and to plan it with help of a system. They work in teams of 3 or 4 students. All teams get a minimum of requirements at the beginning of the semester, but then they have to be creative. And in order to enhance this creativity or to make them more motivated, at the end there is a contest between the teams. So, of course, there is an evaluation by the professor where technical solution, the coverage of requirements, documentation, presentation are important, but the students have to evaluate themselves. So, first of all, in the team, the students have to anonymously express the ways they worked with their colleagues. And then there is this between teams, inter-teams evaluation. Each team has to provide a list, a ranking list of the other teams. And so they want to be higher because they get some extra points for their presentations. That's very short about trying to introduce research in our everyday teaching. And we invite you to come in Bucharest. See you soon. Thank you.
Thank you very much. You were 11 minutes, so that was good. So, so the next speaker, next scheduled speaker is Andrei Parvan. Same university, right? And the title is Innovation as Learning Experience.
I think it's fine. Okay, good. Hello to everyone. I'm glad to be here with you and to be part of this conversation on how to increase the effectiveness and to our well-being and our well-functioning of our universities related to what we expect and we can do for our and with our students, for example. So this is what I want to focus a little today. I have to tell you a little bit about the project. It's a project carried on by universities in Romania, France, Italy, and Slovenia, and we discussed even with the universities. We discussed with the entrepreneurship managers, and also with research institutions. And our focus was to assess how it works, the education enterprise cooperation. So this was the point, as you can see it there. So we discussed in each country with these stakeholders. We also selected and have interviews, someone in person, other one remote interviews due to the pandemic, with the Chamber of Commerce, with NGOs, with public authorities, government institutions or government representatives on the topic. And the main focus, in fact, on the aim is we want to design and to find how can we convert the expertise universities are always, not always, most cases accused of. You've got expertise, you've got skills, you've got knowledge, but you don't transfer it to society. The society doesn't gain from the university. You're still away, far of us. And these are the assertions the public opinion has. Usually the most companies still have, even if things change very better during the last years. So we found out the senior learning facilitator profile being a very good, I think it's no more battery, not even, okay, this works. Okay, I will ask you to to push the space bar, please, instead of me. Okay, so it's only the space bar. I think it will be fine. Okay, so about the methodology and what we have done in Romania, as I told you. So we've got a picture here, 12 academia representatives. 3 from business, 1 from an NGO in open education, and government and public institutions, 2 decision makers in the area. So, what can I tell you more about the academics? 10 of them were R3 and R4 level, and all of them have at least 10 years of experience in the academia. So, thanks. Okay, as may be possible in your countries and in your experience also, these are the things we found. And even if we don't like the situation, we admit we got our perception is as it you may write on the screen. You may read on the screen. Oh, thanks. Okay, and we will discuss, and I will discuss later some of the hurdles related to the cooperation and how the companies, enterprises, and universities work together. So, related to what means education enterprise cooperation in Romania, we found out a couple of list of activities, a list of options universities have related to increase the collaboration between them, of them. So these are the main activities prompted or provided by the interviewers. And here, wait a second. Oh, here is missing. Just a second. There are some slides missing there. Can you see? Can you check it, please? 6, 7, and 8. Yes, they're all. Okay, thank you. So, enterprise education and cooperation in Romania is not about just on teaching, as you see here. So let's move to the. I think we have a problem with the presentation. Let's play it in the working mode. It's safer.
Yeah, okay, I understand that.
Okay, let it as it is now. Okay, thank you. So we got also the issue of valorization and the knowledge transfer, and also, as you may see very soon, in management and participation in clusters and boards. Now, as I told you, I want to discuss a little the barriers in the. Okay, it's fine. The barriers. Okay, it's not so fine. I will be I will pay a lot of attention for now. So, the barriers. We clustered and grouped it into the 5 big categories, classes. Skills mismatching, related to students and to organizational capabilities.
The slides are hidden right here now. I saw that.
I worked it on the Apple, and that's why maybe.
Use the
Pointer. Okay. No, it doesn't. Okay, it's fine now. Thank you. Okay. Now we've got these skills mismatch, and maybe you don't see very well. I'll read them one by one. So in this class, relevance of study programs, quality of education can be also a mismatch. Low-skilled graduates, companies invoke and assert we provide to the labor market. And lack of legislation to support flexible curriculum design. I don't know how it happens in various countries, but the Romanian National Agency for Quality Education has the standards, and the standards are perceived to be barriers for the higher education institutions in designing the study programs. He's building here, that's my fail. So this is lack of mutual trust. So we've got a history of misconducting things, of failures, or different expectations, or inappropriate expectations, and this was the main determinant, the main factor here. Bureaucracy also it is a very difficult one, because we are such a complex society, and it requested also bureaucracy and organizational supports and services on it. And here we've got lack of governmental support. For example, in our country, we don't have a national strategy related to the higher education, and every responsibility is upon each university. And even the support of the national authority, like Ministry of Education and Research, is widely expressed and open expressed. We miss the resources to get that support and to turn that support into convert it into the action. It is related also to the legislation and policy, IPR policy, which is most frequently and lately one of the main topics on the agenda between we and the new wave of enterprises, because it's very difficult to work on the same products and to say, as you know, who is the owner of the for the result of the activity. Also, valorization policy is related, and these each of them is related one to the other. And absence of the dedicated body agency or body related to the policies on topic. And of course, financial resources, as anyone says everywhere, we don't have enough money, we don't have enough opportunities, we are not sure about the future, we cannot budget, and we cannot be sure about grants developed for or mise en place for the topic. As I said also before, was the misaligned goals and inappropriate expectations related to the topic. Okay, we know which are the barriers now. Let's see what can be or which can be the drivers to support education enterprise cooperation. So we got these innovation ecosystems, and every university and every country is very proud of what they already achieved on the topic and on the specialty of each faculty or university. We've got institutional support. The participant also call for, as I said before, a dedicated national agency to support or programs to support education enterprise cooperation. Even we have consortia as in universities, it's very difficult to, it's always very difficult to put on the same table different strategies and different approaches of enterprises, companies, and universities. And this can be a very, very important driver. And as we said before, valorization and legislation, which are linked one to the other. Okay, what's the purpose and why did we do what we have done? We found students and teaching programs and the research programs need someone to make the liaison, the bonding between teaching, research, and converting these expertise for the market and for the enterprise. And we designed this role, this pack of competencies into the role of senior learning facilitator. And we test it in Romania. And I will show you. Yeah, thank you. Okay. And we try to test some options to develop this position in the universities and to say how it. It's
not working?
Today's Tuesday. Okay, 3 bad hours, as we say.
Can you try it again?
Maybe in Turkey it's the same. Okay, that's fine. So we test it, and we test the favorability for the position we design and for the set of skills, for the framework, in fact, we design. And we grouped the opinion into these 3 large categories, as you may see there. As we expected, we've got support, and we got good insights from the people we spoke to, and we found it be very interesting. And here is what we designed finally. So, what is the job description of this senior learning facilitator, and how our interviews and our respondents see the position and the job? So, he may be, or he or she may be involved and have to be involved in activities and services in education. Also, the second one, activities and services in management, and the last one on partnership building. I will take it one by one. Curriculum co-design and inception of training programs, so innovative pedagogies or programs at the university for undergraduate or graduate programs. Training for students and faculty members. In fact, we see this very important not for students, because as professionals, academics, we know, and we already have the, no, we don't know, in fact, we already have our habits and our practice on us, but the senior learning facilitator has a very important role in design and in work with the other members of a community to engage and to enhance and to put together the expertise related to what we are focusing on. So connect faculty members and study programs, as I said before, but this time not inside the main organization, the main faculty, the main department, but also with other departments and with other instances, with other structures. Organize events. So I said in the beginning, I'm very glad to be here and to start this conversation, and we expect for us to interact more, as maybe you do in your universities, to have time to interact and to have the resources to interact and to have the same shared values and the same perspective on the same approaches. And of course, to provide employability analysis. This comes from, as I wrote there and I said before, for a very good understanding, a better understanding of the labor market. Now, nowadays labor market, as ELISA expect, 2030 labor market, 2040 labor market. A very good and very deep understanding. Related to the activities and services in management, define stakeholder segments. And define stakeholder segments and segment and adapt every bond to the specific of the stakeholders. Okay, this is also very important in the project we have. Contribution to study programs and to curricular developments and to curricular assessment, and also developing strategies to support organizational development. Here is also a very important role related to the partnership. We have difficulties to put it here or to let it with the partnership building. And here is maybe one of the most pressing issues: participation in brokeraging events and to business meetings. Connect to the potential partners between them and to the universities also, and facilitate interactions between, not to connect and to feed and to fuel these interactions, and to have an important role in consortia development and consortia specific development related to the specific of the learning design. Not on the last place, representing universities in clusters, in task forces, and related to the government and to the national policies or international policies, transnational policies. So the same model has been tested also in Austria, if I remember very well, in France, Italy, Spain, Slovakia, and is another country I miss now in these seconds. And we expect to have in a couple of months the framework and the skills and how can we train also these senior learning facilitators in order to help universities, economies and societies to become more performant, more effective, and to focus excellence and competencies and performance. Thank you very much. Sorry for the disturbings before. Thank you very much, also.
Thank you. So, next speaker should be Carlos. I have another one, Anna. Anna Goicolea, I'm not sure. Goicolea. From Madrid, right?
Yes. Can I pass the slides or you have it? Can I pass it?
And Anna will be talking about external collaboration for research-based learning. This is the title.
Hello? This doesn't work? Yes? It's working. Thank you for being here, especially at siesta time, which is particularly hard. And my presentation is to show you what we're doing at Universidad Politécnica de Madrid in order to find external funds to develop activities and different experiences such as research-based learning. It can be used for that. And I would like to share our experience so it might be helpful for the rest of the universities, hopefully. Thank you. You probably have heard about industry chairs, but there's no universal definition. Everybody has a different concept of what a university chair is, and but there is some common things that we can say about a university chair. That is a relationship, a long-term relationship, a strategic relationship between a company and the university to put in place different types of activities within a certain technical field of interest for both the industry or the company and the university. The chair is usually formalized with the signature of an agreement in which you set many different things, such as the technical field you're going to focus in, the type of activities you're going to undertake, the duration of the agreement, and the financial endowment that the company is putting to do these activities. This is very different. It goes beyond the contract work that is usually done to do some to solve a problem for a company. This goes beyond this type of relationship. It's a long-term relationship that doesn't end with the termination of a certain work. It's like a framework to develop many different type of activities, okay? And it has many benefits, both for the university and for the companies. And these benefits are many times long-term benefits. They are not, they go beyond the economic benefits in the market for a company, okay? So, for example, for the university, for the academic community, because it includes all the students and the professors and
Recording in progress.
In the first place, they facilitate this relationship between the university and the top-level companies. They put you in the real world. What are the real problems that students have access to? They provide very important, stable funding to engage in activities that take a long term to develop. For example, if you want to start an internship program, you need to have a long-term relationship in order to put that in place. You're not going to do something like that for just 1 year, or maybe you could, but it's not optimal. So being a long-term relationship that provides the framework to put in place long-term activities. It can promote research-based learning. I will give you some examples of some of the chairs at our university that put in place this type of research-based learning within the university, the industry chair. And also it increases the employability of students. it's easier for students that have a relationship with the company to find work after they finish their studies. For companies, it's also very beneficial. They don't get something done for their own benefit in the market, but they get a visibility because these industry chairs always, in every activity they do, they have to promote the name of the company that is funding the activity, so they get very important visibility of their funding. And they also promote training and research in the fields they are interested in. Say, for example, a company needs engineers in a certain specific field. Well, if they put money into, for example, for a master thesis or a final doctoral thesis on a certain specific subject, they will be able to employ those students later on. And they have access to the university resources, to professors, etc. So, it's not working. No. Another one. Okay. Okay. Now. So as I said, the way what I work at the technology transfer office of my university, and what I do is I help professors that have a company and they want to establish, they create a new chair. I help them with the signing of an agreement. And this agreement sets the conditions for the functioning of the chair, and it includes the technological field of interest, the type of activities they want to undertake, the financial endowment, the duration, the location in which school within our university is taking place, and the way of governance. I will go later on the way of governance of companies. These are the types of activities that are typically undertaken within the chairs at the UPM, and they are education and training. They go from student grants, awards for thesis, final degree projects, conferences, seminars, dissemination and knowledge transfer. There are technical and technological dissemination workshops, publications on topics of interest to the chair, and promotion of scientific and technical events, and R&D promotion, R&D projects, and search for funding for projects. So these are the typical activities undertaken in the chairs within our university. And the way these chairs are governed, they have a steering committee that has the same number of members from the university and the industry, and they decide which are the activities they are going to do. Each year they get together, maybe once or twice a year, and they decide which activities they are going to do that year. And there is a parity. They have the same number of members from each part, and they approve the budget for these activities. And then there is the head, that is one of the members of the university in this steering committee, and he's like the visible face of the chair, and he's responsible to do what the steering committee has decided. These are some examples of the chairs at the UPM. I just chose a few to see they are very different in different fields. They totally different fields. Like for the first one is Cátedra Blanca, which is done actually with a company located here in Istanbul. And they do experiments using white concrete. Then we have one with Iberdrola, which is an energy company in Spain. And they do, especially they focus on doing many outreach on development goals. And there's another one with a fertilization company. It's called Fertiberia, and they do congresses, and they give a lot of fellowships to students on these areas. There is another one, Fundacion Sanitas, which is promotes inclusive sports for people with disabilities. Etc. I'm not going to go into all of these, but they are in many different fields, and they do many different activities. But I would like to share with you one that is doing, I think, something very similar to what you are talking here today, research-based learning. And this is Cátedra Blanca, which is with white concrete, and it's done with a company. It's called Simsa. I don't know how to pronounce it. It's a really good opportunity because it takes students from the first year and the fourth year of the degree of the grade, and they have to do work with concrete. They have a special project. Each year is a different project, and they come up with these different figures. Like this year was matter and space for first-year students, and you see all their projects, and then they present them, and they expose. They put them in exhibitions, and they get actually to work. At the beginning, they have 2 projects, individual projects, and at the end of the course, of the workshop, they have a project with they get together to do another project. And they exhibit these are all the students with their different projects. Like this year, they had to do a door with white concrete. And that year was matter and space. And this is the same, but for the 4th year students. And they had to do a lamp with white concrete. So they did very interesting things, and they exhibit them in the Architectural School of Madrid, and they get visibility. There's another one with Telefónica, which is the biggest telecommunications company in Spain, and they do a hackathon with students from all the universities, and it's called For Good, and it's they respond to challenges posed by non-governmental organizations, and there is $48,000 euros in prizes, so the students can participate. These are the figures of the industry chairs in our university. We have more than 70. In the last years, we have, because of the crisis, many of them have ended. But luckily, we still have new companies coming to our university interested in creating a chair. So we still have a pretty high number. And this is the income they generate, is around 1.5 million euros a year that benefit, as I said, the whole community, especially students that are receiving internships, fellowships, etc. This is the distribution by schools. You know that Universidad Politécnica de Madrid has engineers in all of the technological areas and architecture, and some of them use this more like, for example, telecommunications engineer. They have as much as 15. and others don't use them so much. We have collaborations with most of the biggest companies in our country, and also with administrations, also with the ministries. They also can create it's not exclusively for companies, but also for administration and for other entities. So this is all. You want to ask me any question at the end? I would be glad to.
Timing was perfect, exactly. Okay. Okay, so I think it's time for last speaker, Carlos Paredes Bartolomé. Same university. So it's title, STEM learning integrated into a curricular bottom-up metacognitive pathway.
You can use the pointer, but I will share the screen to the Zoom first.
This works. Forward. Okay, good afternoon, everyone. Well, this talk could be considered as complementary information to the other two posters that are outside in the hall. And just to give a brief information about how in our school, because I'm professor in the School of Mines and Energy in the Technical University of Madrid, and how we have developed this idea to introduce research-based learning along some particular subjects in different degrees and master courses. Okay, the ideas start in a small project, well, 2 years of duration, that has been founded in a program of innovation, research and education. It's a particular problem in our university that is about generation and assimilation of knowledge through scientific activation in subjects related with earth science engineering, because our schools developed many different subjects related with earth and earth science and engineering. Well, since the starts today, we have seen a lot of different ideas and what is our situation. Let's say what is our framework to develop the ideas to teach to the students, to promote the information and the knowledge in the students, and just have three aspects that I take in from the talks, because we need to introduce the students into the search for individual talent, because we need to extract what are the main capabilities of different students. We need to identify what are the key skills that we should develop for each student, not only technical skills but also social skills. And finally, provide different technical competences to solve different problems, to innovate in scientific areas, etc. However, we are... Next slide. No.
Can you try it again?
Okay. However, we are living in a real change world. So these ideas maybe are a little bit ancient, and we should always renew the methodologies to introduce in our schools, in our subjects, or in our courses. So first of all, the cognitive learning plus the subject or the contents of the different courses should integrate the information related with mathematics, technology, etc., and engineering to give some kind of proficiencies. They should embrace professional practicum in different enterprises, and they should incorporate social skills, because in the future we will not working alone, always we will working in different teams together. to enhance students' effectiveness with respect to career-oriented academic preparation and meet the challenge in this kind of changing world. So ancient ideas related with working in a separate fields, working individually for each student should be avoided, and open different spaces to promote the communication between students and professors. We should interact between different subjects of different courses. The teachers and the students are engaged in different teamworks, and we should empower students in order to improve their skills and capabilities for socio-professional competences and communication. However, the different actors in the academia have different needs, and we should consider that those needs, first of all, for teachers, wants to find a particular tool or method or a pressure that the subjects in the degree or in the master thesis courses should enable to respond to future needs, particularly related with sustainability. They are not seen in an isolated framework. They should be integrated in a network of knowledge, and an international network of knowledge, and they include outside experience and practicum and human interactions, not only with the students but also with enterprises workers. And of course, all of these kind of procedures or pedagogical methodologies should be immersed in an interesting and motivating learning environment. Students have another different kind of needs. The question is, did you ask to your students what are their needs? Do you have this information to prepare your methodologies or to adapt your methodologies to those needs that have your students, or you didn't? So first of all, what kind of different methods we have used to incorporate those needs in our procedure? First of all, metacognition. Metacognition is a procedure that provokes the critical thinking in the students by means of a cycle. It's a repetitive cycle, but always thinking about what, how, and why we are learning the different subjects. Secondly, we have introduced a different kind of engagement for the actors on each subject and on each course. According to the degree, for example, we have different levels of engagement for the actors, that are the professors and the students. You have a very important engagement for professor here that drives the activity for the students. And in the last case, for example, when the PhD degree is developed, the students takes most of the particular work side or workload instead of the professor. And in this case, the activity is only coordinated by the professor. And you have a constant degree of the intervention and engagement between the different actors. In research-based learning, the idea is to use research to teach, to train, to show different ideas related with the subject. So this is some kind of cocktail that could be prepared, consider the different ingredients in this cocktail. But take care, because you know when you prepare a cocktail with excess of alcoholic doses, the cocktail doesn't work. If you introduce a lot of ice, the flavor is lost. So the ingredients should be introduces in the cocktail with care. To do that, you have different ideas to boost this cocktail, to boost metacognition, to boost research methodology, and to boost the student-teacher role for each year, for each state along the degree or along the master courses. Once the cocktail is prepared, you should take care how to drink it. You should take care you should take care how you manage professors, because you can find some situations that could be managed properly. For example, due to the workload for your students, you can find some professor, some colleague, knocking to your door and asking, hey you, what are you doing with our students? Because they have such a workload that they are not going to my courses. So please stop it. And you should manage this situation. Otherwise, you should take care with your students. Because yes, of course, your course is really important. And you are using a very innovative technology or methodology, research-based learning. Oh my goodness. And this is really important, and your students know that. But take care, because that supposes a very important workload to your students. So maybe your students go really exhausted with your activity. So take care with these kind of methodologies, because could be really boosted and affected to the surroundings in your department, or also in the whole of the degree, for example. If you consider different states or different courses along the degree. So you should decide how to prepare your students, as you told them or as you ask them. Finally, they want to be self-directed learners and evaluate their own knowledge with their own skills, technical and social skills, and plan their approach through a metacognitive procedure that always thinking about how, what, and why are they doing that things, because that reinforce this knowledge and creates the critical thinking. Okay? So, thank you very much. You have different approaches using this methodology outside in the hall. So that's all. Thank you very much.
Okay. Okay, thank you very much. So we are only 15 minutes late. So it's we kept on time since I was 15 minutes late in the beginning, so it's my fault. Okay, and but we have 10 minutes. Question and answers session scheduled. So if there's any question.
Hi, thanks everyone for their presentations. I wanted to ask Maria Ionela, Mrs. Okay, thank you. I wonder what happens to students' projects after you grade them. Like, do some of them get applied?
Some of the, thank you. So some of the students involved in their final research parts of the project. Basically, because it's a project related to a course, they are not going to implement, as you have seen the topic of this semester. It's a very large topic. They are not able in 14 weeks to implement it. They have to concept the idea, to present a concept. So it's they stop at the project phase. They have to say what's overall architecture, what are the modules, how they they plan to implement it, but they are not coming till the implementation. They don't have time for this, but some of them take parts and ideas and include them in their final projects, dissertation projects.
Okay, thank you.
I'd like to ask Professor Bartolome. I'm sorry, Paredes. Did you fund this project with your own resources, or maybe I missed the first part, if it's EU funded project, or how did you manage to
well, actually, there is no funding for this kind of projects because for the first shot, that was founded, and also in a particular framework related with pandemic. So we start with that within pandemics, and it works. Not really a very high number of students, but it works. And actually, there is no funding with that. But I continue with this idea. But not only me, because this takes, let's say, 4 different departments. So against to avoid the effect, the silo effect, that's this morning Professor Krishnamurti talked about, the silo effect, you should break the walls between different departments to avoid this concrete bubble around departments, to use the resources, to use the professors, to use the laboratories. And this is a really transdisciplinary methodology, and you need that. Research-based learning is not a methodology in one subject, only one, let's say mathematics. No, you should take in account mathematics, computer methodology, and let's say materials, or hydrogeology, and water resources. To get the complete idea of the problem, you need to manage water, yes, but you need to know how water moves, how to study the water movement, and how to get information from water holes, and then how to manage the water resources, for example. So this is a long way through maybe 4 years, but this is not founded, actually.
Do you think that we can use this project, for example, as a pilot project to implement in Turkey or in other parts of Europe? Yeah? Okay.
Remember the cocktail.
Okay. Thank you.
And shake with care.
Okay. Thanks.
So this is the part where I start my presentation, the hypothesis for my presentation. The second part is that research data is always an essential part of creating science knowledge. And I will not be an advocate for research data, because we all know the benefits of opening research data, right? From reproducibility to actually making sure that researchers are more trustable at the end of the day. So lots and lots of advantages. Okay, let's talk a little bit about ELISA communities. You all already probably know about it. Basically, these communities are working groups where citizens, private companies, academia, all combine and work together, collaborate to face societal challenges, right? So, building on the ecosystem of these ELISA communities, ELISA InnoCore, the other project, focuses on the R&I dimension of the alliance in a 3-step plan, okay? So how can we optimize the outreach of the research activities such that in the end to benefit better the communities that are created in the ELISA project? Okay, and this is the idea that I want to pose here as a slide, just as a debate focus, let's say, a challenge for everyone. University need to work together to create a training environment where students learn in their own pace, probably through experimentation, the use of digital technologies, by actively working with data and application over smart remote laboratories. What does it mean in reality? Basically, we all have tools behind our work, right? So in my research activities, I'm also a researcher like everyone else. I create a lot of new ideas, new experiments, and these experiments are more or less based on tools. And also, through these experiments, lots and lots of data is being produced, right? So why not actually put to use all these tools and instruments such that in the end to benefit our own students from them, okay? So in my own classes, of course I can do that. And my own classes are constructed in such a way that through the applications part of the classes, students get engaged and actually they start using IoT instruments, for example, simulators, for example, and also they use data, right? So I give them data. I have data for smart cities, for example, because this is a part of my own research activity. And I actually challenge them, okay, you have this data. We have this nice simulator that is based on the data in the city, and you can do whatever you want in what-if scenarios with the data. Just please come up with your own concepts and prove yourself that you actually have what it takes, the critical thinking parts that actually are required in my own classes, okay? However, how do we actually open these kind of laboratories to the outward? And this is a challenge, actually. But, however, this also is possible, and I will show you how. And then the second idea is the concept of smart laboratories. Again, this is not a new concept. People were talking about smart laboratories for several years now. Basically, by combining smart laboratories with data, we can actually support new activities in terms of online training for smart specialization technologies, for example, and also support new innovation activities and outcomes through common data procreation. Let me show you what we have at UPB, University Polytechnic in Bucharest. So we are located in the capital city of Romania. We have a nice building. It's called the Institute of Research Precis. And the institute is completely dedicated to research activities. So we have many laboratories dedicated from IoT to hardware construction and several others, right? In this laboratory, students can work. So they can come in, ask about activities, ask about what they can actually do to learn new skills. Okay, and this is the concept that I would propose to everyone here. Basically, the concept would be, in terms of learning methodologies, we already have several extreme cases, right? Through the offline activities, students are basically learning in your classes. They come to your university, they are admitted in admission process, and then basically they go in and take the classes through that are basically dictated by, or somehow, by the methodology of the university, right? Then you have the other way around, the Erasmus activities, where students actually go through one university and they choose to go in another university for one entire semester. And that's it. I mean, this is not the case like, for example, a student could actually choose a class from, for example, just an example, from Italy, but in the same semester take a class from, for example, in France, in Paris. In the same semester take one in Istanbul. How can we do that? through smart laboratories. Open the laboratories, make them available to everyone else around you. Okay, so how can we do that? By interconnecting laboratories. Of course, we have several challenges we need to solve here by creating basically the instruments centered around data orientation, so open the data to everyone, and also, of course, update the education activities. Okay, now let me go to two different projects. So they are both Erasmus projects. Sorry, did I do something here? No worries, okay. Okay, good. So, the first project. Okay. The first project is called Train RDM. The second one is called Education 4.0. In Train RDM, we have partners from all around Europe, like in all Erasmus projects. And like in all Erasmus projects, we face the same challenge. Okay, how do you conduct the training activities? And in the Erasmus project, let me tell you how it's usually done, basically, right? You put a Moodle instance somewhere centralized, and everyone actually uploads their content in that particular Moodle instance. Of course, this is a huge problem in the end. The centralized learning activity in Erasmus suffers from the IPR parts, because usually the people creating the content are not really happy to upload the content to somewhere else's site, the platform outside the university, right? So we asked ourselves, can we actually construct a distributed learning platform? What would it take actually to construct something like that? And we actually started the project with this nice questionnaire that was filled in by not only the partners in the project, but many, many others. Okay, and we wanted to see exactly what kind of tools we can rely on, and what tools and what data and how the tools are working. And I cannot now change again. Sorry about that. Okay, yes. The good news, everyone is using Moodle, more or less, right? So probably you've all heard about Moodle, the Moodle learning platform. Yeah, this is the good news, because actually we can combine the Moodle platforms. The second one, is there actually some methodologies available already such that to support the opening of the data? Do you have methodologies to support open science in particular and everything else? And yes, people are starting to actually understand better this kind of new science directions, let's say, with opening the data, opening access to articles and everything else. People are actually starting already to not only promote open science, but include learning activities in open science in all universities, right? And I give you here some examples from Ireland, who is not even part of ELISA here. They have many, many classes actually oriented on, around the concept of open science. Okay, third one is about the data itself and how the data is protected in different institutions. And we gladly found out that many are using CRIS repositories. Probably you all know what CRIS is. So basically all universities use repositories where they store data for researchers and about researchers, right? So research activities are there in terms of publications, for example, or even projects, and also patents. Okay, then in terms of authorization, so in order to open the Moodle platforms and every other platform available in terms of the technology, the biggest challenge here is how can we connect them in terms of authorization access priorities or technologies here. So the accounts, for the account creation in different institutions, there are several technologies being used, from LDAP to SAMLE, for example. However, everyone is using Keycloak, for example. Keycloak actually embraces all these technologies together in the authorization and authentication part. And this is also a part that is good news for everyone, because actually you can combine all the authorization systems in one single place. So the solution is this one. And again, you probably already heard of EduRoam, right? Because you are connected right now to EduRoam for connectivity, right? EduGain is the same thing for services. So if EduRoam does something for connectivity, like actually allowing you with your own credentials from your own institution to access the internet, EduGain is the same initiative in terms of educational services, right? So by using again your same account in your own institution, you can already authorize and enter into the systems into another university. Services being published by another university, like here, for example, in Istanbul, right? If, for example, Istanbul would be part of EduGain, basically with my own credential, I could access any class available in the Moodle instance here at the university. That's the idea of EduGain. It's nice. Okay. Then, this is about, again, how can we combine not only the Moodle instances, but also the data repositories, and we have many data repositories available. For example, in some institutions, universities are using Dataverse, being deployed or developed by Harvard University. In some other institutions, and many more than Dataverse, actually are using CCAN, for example, right? CCAN is more, let's say, extendable, because this one is quite closed. I mean, it's open again, but it comes with a Docker container, which is not really the compilation of the open source that is available in the open repository here. However, here you know that what you get is exactly what is in the open source repository there. So this is why actually people are preferring CCAN over Dataverse. But these are the two most available or used basically open data repositories, institution repositories. How would such an interconnected world look like? For example, basically I could actually publish as a service my CCAN repository at UPB, right? What does it mean? That anyone can now access this repository with the credentials from the own institution, local institution. So in this case, for example, a student in my institution would actually access institutional credentials here and already have access to the repository of data here at the University di Rome, for example, Sapientia. Okay, this is the first project. And this is exactly what we already done. This is exactly something that is work in progress. I mean, we are in the testing phase. Now, the second project, which just started, but already has a good, startup, okay, it's called Education 4.0. This one is dedicated exactly to the creation of the smart laboratories, let's say. So digital laboratories, not only about interconnected platforms or services, but even more than that. And of course, we started already here with the same concept that we want to analyze what we have already in the different institutions involved, different universities, just to see what kind of technology we can rely on. And this is the concept that actually naturally emerged. Many are using Jupyter notebooks for their own research activities, which is good news again. Again, because everyone knows about it. People are really happy about it because Jupyter notebooks allow you for easily reproducibility of your own research, not only data, but how you get to the data, experimentation process, and everything else, of course. And then there is Jupyter Hub, which gives user access to computational environments. So you don't have to worry anymore, how do you run these Jupyter notebooks, where is the environment, how do you get to reproduce the experiments. Basically, Jupyter Hub is comes to the rescue here. So the concept is this one, with this project. Basically, the laboratories for different classes could couple not only the Moodle instances or the data available in different institutions, but actually through Jupyter, you can actually push the knowledge to students outside your own university. So basically, again, use EduGain to allow for interconnections of Jupyter labs where Jupyter notebooks are being run. So now you have a completely dedicated activity for one class being formed by different classes or applications already implemented in Jupyter notebooks. Of course, behind it you have the data available, behind it you have the classes in the Moodle available. So now we are truly talking about an interconnected learning environment for our students, where just by actually also thinking of the methodology to actually couple also the institutional processes all together, yes, in the future probably, I would be happy to host a student in the middle of semester from Istanbul here to take a class in my place at UPB. Yeah, that was my idea of a challenge, of a debate, if you want, for today. Okay, so this is exactly how we envision the future. The first class is here. We already, in the first Erasmus project, in the Train RDM project, we already developed an interconnected master project, basically a master class or courses or curricula all together. And you can see here that 1, 2, 3, 4 different universities are actually working together in the same master program. Yeah, and this is already happening. Thank you.
Thank you very much. Okay. The questions will be at the end of the session. Yes. So now I have to invite Mr. Gianfranco. Yes, he is online, yes? No. No?
It's not online.
Yes. Yes.
I have a presentation,
but he is, we don't have a sound.
Put him up there now.
One moment, please.
Okay.
So, please, can you hear us?
Hayır, ama bu bilgisayarın ki yok, ses buradan gelmiyor.
He is not. Is he?
I'm checking his microphone, but it's open. Bu arka taraftan alıyoruz, buradan almıyoruz sesi. O bilgisayarın sesi. Let me check him.
I suggest the following. We step to the next presentation, and in the meantime, you try to connect them. Is it possible?
Sure. If he will wait.
Is he waiting? Okay, okay.
Yeah.
Okay, okay. Then please start presenting.
So thank you very much for the introduction, and apologize for not being here for there and share with you my own experience. I entitled my presentation about Breaking the Wall, Theory or Practice, Classical Archaeology, Field Activity, and on-site teaching. I would like to show you a possibility to open a new way for the students to practice and to have a good moment in theoretical practice in the field of archaeology. As you may know, the title comes from a very influential song by the Pink Floyd. But in this case, instead of an ugly teacher and very bad school system, I would like to introduce a more positive nuance to this title, another brick in the wall in terms of research-based learning, but also research-based teaching. I think we have to put in mind that building knowledge is very important, and it's our main purpose as professors or researchers. But to go further, and this is also the challenge of the EELISA network, we have to break this wall and to break notions, as we just heard from the previous speaker. And the challenge is something that in my field could be summarized as from the known to the unknown. And archaeology, classical archaeology, is a good issue, a good topic to discuss the research-based learning and teaching. Unfortunately, the discipline, as many other disciplines, not only in classics, is divided by a huge wall. On one side, we have archaeology, that means field activity, field archaeology. On the other side, we have art history. That means theory and practice of art, such as sculpture or architecture. In the past, the division has been very, very strong and very systematic into my discipline. But today, I would like to break the wall and to put other bricks in the wall. For instance, usually in the class, I can talk about the Acropolis of Athens. This is a fantastic aerial view. And then I can show the monuments on a plan that is very schematic, very simple, very intelligible by the students, undergraduate students and PhD students. But the on-site activity could open towards a new world, a new field. Again, we can give many notions. We provide a lot of notions on a small temple like this one, of the temple of the Athena Nike on the bastion of the Acropolis. But it's a different experience in terms of architecture, dimension, landscape, relationship between monuments and the city, when I can teach all these issues on site. And this is something occurred in the past. And after 2 years of pandemic situation, in June, I will start with the on-site teaching, asking also for guided tour by some architects. In this case is you can see Tassos Stanoulas, who was the conservator of this part of the Acropolis. And the same could say for the Parthenon building, a huge building. So we have plans, we have nice drawings, but again, the experience to be, in this case, on the scaffoldings of the Parthenon during the restoration of the monument allows students to have a totally different perspective of the monument, of the current state of art of the discipline, because in this case, the discussion was about the restoration of an ancient building like the Parthenon. And this on-site teaching includes, as just said, eminent experts, like in this case, Jennifer Niles, director of the American School of Classical Studies in Athens. Here we are at the Acropolis Museum in Athens, just in front of the architectural monuments and decorations of the Parthenon. And also the another part of the Acropolis, the Propylaea, with another different perspective within the building, and try to understand the ancient and contemporary issues related not only to the construction and the building of this monument, but also the current position, in this case, of the Greek colleagues regarding the restoration and the accessibility of the monuments of the past. Just to give also a nice view from Turkey, students are also involved in this experience, since they are asked by myself to present monuments. This is the visit to many important archaeological places in Turkey, like Didyma, Millet, and Priene, and you can see the students presenting their specific monuments. But the experience could be really a surprise, like the case of the Temple of Apollo at Bassa in the Peloponnese. Here in the upper part you can see a nice drawing of the plan, and this is bottom right the real situation of the temple, totally inaccessible from the external. But thanks to the on-site visit, we are allowed to go into the tent and visit this fantastic monument that is unfortunately for preservation reasons totally covered and not accessible from the external. But this is the easy part, I should say. The difficult task for me, but also for the student, is when we move from the known notions, because we can discuss about the Parthenon and other monuments in classes, but in museum, for instance, the situation is totally different. Students are asked to comment or to answer about a specific monument, and usually the answer is, I've never seen it before. But this is the challenge. Thanks to the notions they acquired during classes, they have to build a story, a biography, a narrative around the monuments. So you can see the students trying to read an inscription on a base in Athens, or other students looking at Roman portraits. So they have to identify, for instance, the person represented and sculpted in marble, and try to give them a chronology and try to understand the context where the portrait was displayed in ancient times. So the museum offers a challenging situation for them, and it's always something interesting in terms of research-based teaching and learning, because they must be focused on the archaeological pieces, and they have to give reliable answers to the specific monuments. And for this reason, the on-site teaching and learning includes also important museums and collections like the British Museum. A different situation is a similar situation from the unknown to the known aspects is what happens during an excavation. Here I would like to introduce you to my field experience in Agrigento in Sicily, and this is the ancient city of Agrigento, and the Temple D is our area of research. And the research has started 2 years ago, so this year September will be the third season. Why the excavation is so important to us? Because again, we have a very well-known temple, a 5th century temple, but we would like to investigate what happened around and inside the temple. So just to give you an idea of the area already under discussion, we had the possibility to excavate the area around the peristasis. Another trench was into the 5th century altar. Another one was in the northern part of the sanctuary, and a last trench inside the cella. The most important things in terms of research-based learning and teaching is the responsibility of the students. So the students are supervising the trenches. Of course, I'm supervising the entire excavation, but in terms of responsibility, the students are in charge with the excavation itself. And in this case, for instance, thinking again of another brick in the wall, we can start from the stratigraphy. So you can teach what the stratigraphy is, and you can recognize the different composition of the terrain, the excavation, and this is the direct contact of the students in terms of practice and theory, since you can explain what stratigraphy is with a nice drawing, but it's more difficult when you have to single out how a specific area of the stratigraphy is characterized by materials or composition of the terrain. From the stratigraphy, from the different strata, we have materials. Actually, during the discovery, it's quite impossible to understand what kind of materials we are dealing with, but thanks to the cleaning, and this is roughly the process we usually have in terms of cleaning the materials, we can be aware of the materials. The materials are very important in this case because sometimes we have the possibility to date, thanks to the materials, the different strata. In principle, we have drawing, so the students have to learn how to draw a fragment of ceramics, for instance, or a fragment of architecture. And the drawing is very, very important because thanks to the shape, we can classify it and then we can date it. So it's very important to have a very, very good knowledge of the materials. And this will allow us to go deeper and try to better understand what happens during a specific day, decade, or century in that specific archaeological context. In this case, the challenge is to start from a fragment, apparently a mute, unfriendly fragment of pottery. But thanks to the drawing, you can see in the case of this, sorry for being so technical, the Silhouette Goat Painter 1 cup, we can recognize the shape of the ceramic, so it's a cup, and thanks to the drawing on the shape, we can date this cup around 580 BCE. That is an important chronology since the archaeological site of Agrigento was founded exactly in that period. And this cup, this drawing, the specific color and decoration allows us to refer this fragment to the production of Corinth in Greece. So this fragment and the cup was transported from Corinth to Agrigento during the very beginning of the 6th century. So again, we can build a biography around this specific fragment. At the same time, from the same context, we had this Siena cup by the painter C, and we know that the painter C comes from Athens. So we have a different story, a different biography of this vase. It is a cup, but is a different typology of cup. So we can build also on this fragment, and the students can acquire more knowledge and notions from apparently unknown fragments. And this is also what happens with the discovery of architectural fragments from the same location. We know that the temple was built during the middle of the 5th century BCE, but we found fragments of archaic architectural decoration with polychromy, and thanks to the comparison with another temple in Agrigento, we can date those two fragments, apparently insignificant, two fragments at all, but thanks to the chronology of these two fragments, 540, 530, last year we understood that beneath the classical temple there must be an archaic temple with terracotta architectural decoration, as the two pieces that I'm presenting to you today. So just to come towards an end, I think that the engagement of the students and the apparently disciplinary division in classical archaeology between archaeology and art history can be overcome through a good combination of good practices, of theory and practice in field archaeology, in on-site visit, and also on art historical practices. I think that the crossing disciplinary boundaries and open also the discipline towards more technical and technologies, more advanced technologies, will allow us to have also a different perspective of our discipline, and it's a good experience for both theory and practice in our field. And just to conclude my short presentation, in September 2022, there will be the first summer school organized by the EELISA network. That includes Scuola Normale, ITU, Scuola Sant'Anna, and UPM from Madrid. So I think that in this way we can put another brick in the wall to build the future of our students. Thank you very much for your attention.
Thank you also. And the questions will come at the end of the all presentations. So now I invite, yes, please. I don't know how to pronounce very well your name, so maybe you say.
Maybe. So it is very nice to be here. Oh, okay. Excuse me. Okay. So it is very nice to be here. It is the discussion and presentations are great. I'm a professor in Istanbul Technical University, so I would like to share with you my experience in my studies, in my lectures, or in my classes. So then, if I go to how I just jump into this, this actually it is just the experience I can tell you. I'm gonna share with you. My motivation, I have been teaching actually in my classes. I have been using in the research-based studies, research-based projects in my classes. Then I like to continue with the development and contribution and engagement with my students in class also. So we know we have been talking the different learning methodologies. There are lots of different learning methodologies. We know actually also in our classes, when we look at the different students, they have a different ability or capabilities. This is my question when I started teaching, training students. So it is also continuous in the future as well. These different abilities, I thought we can't just look at exams. I can't. I mean, I should use different methodologies. So what we are doing in universities, we are training our students with this community, producing universal knowledge, which also I like to tell education is a kind of hope. All of us, actually. It is very important. It is critical as well. So this experience of mine, when I look into all these strategies and learning processes, which I need to improve, and I need to just pull all my students in my class. Otherwise, just exams, not solution. So I look at the learning processes, and when we look at it, actually I'm gonna continue each one of them by in my also this experience and this search. And if we look at, there is some parts of these old studies, this education methodology studies, they have lots of same subjects, same results. So, so that when I go through, of course, also this all educational methodology, different methodology, capacity of the university campus, so on, attracting, impacting students as well. At the same time, when I looking and thinking, is there any relationship with the generalization learning? I mean, what does it mean? We know that we have been using this actually. We have been talking about that. There's a lot of research at the same time, and millennials and different generation, if there is impacting our learning process. There's a different opinion about that. So, for example, some of them they are thinking there is no any this generational learning or teaching process, but also there is a, sorry about that. This is also okay. So again here there is a similarity, some critical points with the training process. So then also when we look at this all modern teaching, There are lots of different teaching methodologies, newest teaching or learning methodologies. In these methodologies, all of them, when we look at, there are different, as you see, learning methods. And also, if you go through all of them, each one of them, actually, each one of them is related with the research base. Part of the research base, I can tell. So in this, what we are doing, we are giving subjects, or in the class, I mean. In the class, we are sharing our students subjects, different problems, live problems. It could be actual problems or theoretical problems. And we are expecting they can collect information and get their results and present all their results in the class. So mainly it is the process working as much as which I taught. And there's also, especially latest 20 years, 25, 30 years, European universities, which they are here, they have been looking at this changing world and what we can do about that. Changing education. And in their studies, their reports, they also discussed this research-based learning process. I like to, I'm not using the word teaching, which is learning is most important, or training most important. So, which I am also learning, still learning. In their studies, there's I'm gonna go through, not each one, I'm not mentioning each one of them, but lots of very important studies, research we can find. And they are also explaining how this process working, which I shared my experience, what I am doing in my classes. If we go through, if I just use several sentences, my curiosity to look at what they are doing, what is the results, and what is the highlights of this research. If I go through for example here, let me go back here, as you can see, all of them saying such methodologies which have been talking. We have been talking. So I like to look at what's happening. If it is change my students' results, what's happening? This is, of course, this is not wide study of mine. This is basic study, which I look over it. And in here, I took several classes and look at the before pandemic term, and this is before one. And you can see they have exams, and this red one showing project studies of my students. If I continue different term, this is pandemic period. So you can see again project-based studies, higher score, since they are engaging and they are producing their results. This is another one. So if I go through, look at the correlation, and there is what is the correlation between them, how they impact my students. It seems that they are, of course, not just these numbers. Of course, this is just the numbers or scores, we can tell. But as far as I can tell, my students influence, they impacted because of their projects. Their return opinion or thoughts about the projects will learn what you are saying in the projects. Otherwise, in the exam, I'm just traditional, of course, learning process probably. We have been using around the globe 200 years. But now, especially in the pandemic term, new techniques, learning techniques, or methodologies, we can tell, we need to look over what they are. So this, again, I just highlighted some of them. I'm going to continue with of course, what they are. For example, some highlight here, and knowledge, organizing knowledge, acquiring component skills, and so social, emotional changing and intellectual change as well. If we go through, what is the advantages? As I told you, face-to-face, or sometimes by using online study with my students, they share, as I told you, and here the advantages they had gained capabilities in the learning process. They got critical thinking, and also another example. We went with them. I went with them in different countries, presenting their projects. They just produce in the class, and we just go in other countries to make their presentations. So then also some of professor in previous session here also talk about that. We have advantages, of course. It is clear. Changing world, changing technologies, and so on. Also, we need to look at disadvantages, workloads, not just students, but also us. And what is the, also another professor talk about this open source. It is huge. We have been using. I can use my model with another country's supercomputers by using their computers, or open source data, so on. It is very, very, good for us. Very important for our research as well. So our students can do this. But do we need new facilities? Do we have enough facilities? The question is how we are going to continue this research-based learning. And as I told you, all these processes, this is great. I'm very lucky to have you here. It is a pleasure for me. But the end of all this discussion, we need to ask the students to improving, developing this research-based curriculum. Also, another disadvantage could be if I am teaching, I am using learning, research-based learning, I need assistance. Or I can share my thought, my project, student project, lecture class project, other class. It can be multi-research-based learning process as well. So my remarks is we need to rethink university. What's going to be 21st century university? Students should be part of the learning process. And how students can be active participant in the class. How they are asking question. How many questions they are asking. If they are asking or not asking any question. And active learning, which I told, and encouraging student curiosity. I mean, it is and talent as well. In here, motivation, also another important part of the research-based learning process. So the study says, as you see, that the part of the learning process, each one of them, each percentage, and if we can teach them, students, with research-based projects, they talk about each other, engage these research projects, and after all, they can teach each other. So the learning process, which is the research-based learning process or other modern learning processes, important that are next research studies, not just studies, also education in university. So thanks, of course, and then this is the also my question: is there any relation with the climate change or unsustainable world and with our higher education? So thanks for your attention.
Thank you very much. Thank you very much. I invite now Paul Rambach to present his prepared presentation, and I am already waiting for the discussion in the end. Please.
Okay, thanks. Thank you for hosting this session, and many thanks to the organizers of this great event. Also, thank you for the technical assistance. It's not always the easiest job, so thanks. My name is Paul Rambach, and I work at École des Ponts as the academic advisor of the Mechanical Engineering and Material Sciences department. In this presentation, I will share with you the students' projects we make in our department and how we collaborate with external partners. So here is the architecture of my presentation. After briefly discussing the difference between the French system of École d'ingénieurs, engineering school, and the university system. I will start with the obvious, that is, there is a shared desire for collaborate between us, the academic part, and the industrial part. I will then proceed on how to act on, I will say how we act on this shared envy to collaborate. Afterwards, I will show how what we think the backbone of such a student project is. Finally, what is gained for the student during carrying out such projects. And as a conclusion remarks, the good practices we have learned over the years. You all know that a bachelor degree is 3 years long and a master degree 2 years. But in our École d'ingénieurs, we said we'll do it otherwise. So after 2 years of intense preparatory classes where there are lots of mathematics, physics, the students take an exam to enter an École d'ingénieurs. And then it is a 3-year program. At École des Ponts, the first year is again core courses and again a lot of mathematics and physics. And afterwards, they join a department within they specialize. In my department, we created for the second year another track, because there used to be only one track, and it was the classical, historical one, where which is still open and chosen for certain students. But we realized that there are two types of students. There are the ones that understand physics through the equations, so they can know when to kill a term and what it means at the end of the trick, and so they can interpret the world through the equations. But there are also different types of students that understand the equation through physics experiment. And this second type of students were not happy following the classical track. So we opened a new track, and this is mainly the one I will speak about, because it is one where there is a lot of projects. Then the rest of the year is usually they follow a year of internship, and then they go either on a research master or at a different university. So now that we are clear on the difference between the students we have and the one you can have at university, I will say why there is a collaboration between us and the industrial partner or research partners. The upside for the industrial partner is quite easy to understand. They have eyes on a future engineer. They want to recruit them, so they want to catch them before they got before they graduate. And also, it is a way for them to gain access to the academic body and speak and tell them what they think should be taught to the students, because there are some needs at the industrial level that are not met with the teachings we offer. As to us, the academic partner, what we gain from this collaboration is that we have tangible and concrete subjects for our projects, and this is more engaging than maybe some hypothetical projects. Also, we create bonds with these industrial partners, and we gain visibility to recruit new students and have a lot of students. So this is why we share the desire to collaborate. But what we can see is that even though we want to collaborate, we have different objectives, and we have to acknowledge that, because otherwise the projects may just go not as well as planned. So we think there are 2 points really that we have to follow, that the projects should not be on the partner critical path. And this is because we cannot say we will succeed in performing and carrying out the projects up to its end. What we say is that we will work as hard as possible to try and get to the end result. So this is something that needs to be clear between us and the industrial partner. So we collaborate, but on what kind of projects can we collaborate? Here is a bit of a confession, because we carry out projects with usually people that we already know. It's easier because they know us, they know how we work, and so they usually tend to be former students that go into global big companies or small-scale startups. But it is easier to work with people we already know. So this is a bit tricky to get new collaboration partners. Also, a point that needs to be addressed is that the projects have to be aligned with the courses taught, because a project takes a lot of amount of time, and if it's in no way near a course, the students will not see the point in doing the projects. Also, by doing so, they have to work a bit less for the course related to. Here are 3 examples of what we can do. Plastic recycling. So behind that is that the plastic used for 3D printing, it's shredded and then remelted and then again filed in a coil shape and then reused. So this is one of the projects we do. Agricultural robot. This is a robot that is meant to help get rid of weeds in a lettuce field, for instance. And inspection drones. This is also another type of project which involves a lot of coding, but still goes to in the range of mechanical engineering. So I said that we need to be really clear on how to interweave the projects and the courses, and this is the way we did it. When the students join the department, they have very little workable skills to tackle the issues that the projects are demanding. So we think that there are 4 types of learnings that need to be given before the actual prototype is made. And there are tools like a computer-aided design or finite element modeling. Also some modelization, so the equation cannot be avoided at all times. Finally, robotics and programming. So if you on the right side of the slide, you see how it is the proportionality of the different courses on the semester. So the blanks are not resting moments for the students. They have languages, humanities, sports. So this makes that the first semester is very demanding for the students, because they have to learn a lot before really projecting into the project. So the backbone of a project for us is as follows. The project is carried out during the whole year. But since they have to learn a lot during the first semester, they do not work that much on it. And also, there are two reasons, because they cannot really work on it, and also because there is a time needed to understand and apprehend the project. So to do some bibliography, see what other people have done on such topics, on related topics. And this is the objectives that we set for these first semesters. We ask them to define the specification and their objectives, because the project is not, it has to be taken into, has to be what the students want it to be. So they have to say what they will do and how they will do. Also, they have to say how, they have to plan the things they will do. And also this helps them to project in the near future, and it sets milestones on their projects. So. And at the end of the first semester, they have to build a first prototype. So this is something that we ask. They have to produce something before the end of the semester. The second semesters, they work much more on their projects at the rate of two days per week. And this is when they really execute their project. And they either revise the schedule or they follow it, but they have to take notes, and at the end, and in the final report, they have to say their initial schedule and what make them change it, and what were the delayed, and why they and how they solve the issues. At the end of the year, they have to produce a functional demonstrator, and this is and it is set in the main hall of the school, in front of everybody else, the students, the academic part, the head of the school. So this is the way to this is to make them realize that they cannot show empty-handed, or they will look like fools in front of everyone. So this is quite an incentive, efficient. It is quite efficient to make them work. Another part of what makes a project is the teams. We think that 3 people teams is the right amount of people. Over 3, the risk of free rider is increasing, and under 3, it's not really a team. So if one decides not to work, it can then condemn the group to not work at all on the project. So 3 people teams we think is the right amount of people. Also, the objectives of working in teams are that they don't choose the partner, they choose the subject that they want to work on, but they have to work with people that maybe they don't like. But this is what they will have in the real life when they work in companies. They have to work with people they not necessarily like, and they have to cope with that. And also, we don't have the time to teach them soft skills in project management. So this is a way for them to also learn it by doing it. They learn the soft skills that project management involve. And finally, as I said, the specific order from the collaborator helps them project. They see why and how it can be in their future life as a working citizen. Okay. What is gained from the students by carrying out such projects? Videos or communication skills that we ask them during the project. About half the second semester, we ask them to produce kind of a short and funny video, a short video clip on their project. So this is the agricultural robot on the left and the inspection drone on the right. And we use these videos as advertising to recruit the next generation of people. So we use the students to recruit new students. Like the first year, they see these videos, they see, oh, it's funny, and we want to join the mechanical department. And also, it helps them develop communication skills. A key point for the student is that they devise, construct, and test the solution that they came up with. It's their solution, and it has to work. So they are helped with a researcher or industrial partner, but this is their solution. Also, what they gain is to manage knowledge transfer. I mean, some projects are continuing over time, so the final report has to be enough for the next year, to the group, the following year group, to continue the work. And this is something that sometimes in research we lost what the other people have done, and in a way we try to teach them that if the work they do is lost just the next year, it is a complete loss of time and money for everybody. So they have to make something that we can work on later without them. Also, they are more confident in what they can do. They see that from the abstract world of equation, they can translate it, and they can work something that is, they can build something that works, and this is something really great, I think, for the student. And as I said, the project management for the soft skills, maybe mind maps, Gantt charts, budget. They have to they manage the budget. So this all that soft skills that we cannot teach, we don't have time, and they learn it by using. So finally, what are the good practices we have learned over the years is that the projects need to be anchored in a concrete environment. It cannot be hypothetical. It has to be a real industrial or research thing. The syllabus must be in agreement with the project's needs. So when we created the new tracks, we made sure that the courses were the ones that the students needed to then build and spend a lot of time during the second semester. So we created a complete new track, and this was by doing so we did that by creating the syllabus in agreement with the projects. Something that must be done is the follow-up meeting with the supervisor, and this has to be done every week, no matter what, because so the supervisor and the students keep motivated and they keep working. If they, for one reason or another, decide to not do and not follow this follow-up meeting, the projects goes. The chances that the project will not work at the end. It has to be something that must be done. Right. Also, the students have to move to the prototyping phase as soon as possible, because as long as no one does anything, everything works fine. And the second you start building something, everything goes awry, and so this is the real problems happen when we start building. Also, specific milestone throughout the year must be set. We think that because they can see and they can project themselves in the future, and so they know what they will do, And when they look backwards, they will know what went wrong and if they followed what they said they would be doing. And the takeaway message is make. Something has to be created, and in making you do mistakes and you learn from the mistakes. Thank you.
Thank you very much for all the presentations. They were all very interesting, and I'm sure you would like to put some questions to debate. They were different, but also similar in their intent to bring the students make something in the end. So please, who wants to formulate the first question? I have a short question. How many students are involved in such projects in 1 year, in one academic year?
Alors, so we deal with very few people at École des Ponts. In my department, there are like 50 students per year. And if you divide it into 2 tracks, it makes like 50-50, so there are like more 30 people doing projects, so this means 10 projects per year.
Okay, thank you very much, because I think many of us were thinking about this scaling problem. If we have 400 students in a year, then it's quite complicated. Please, the next question.
Thank you. I have a question related with the responsibility that you consider once the enterprise have give you the project, for example. How do you assume this kind of responsibility? Because maybe the project could fail, or we assume that we have always success. And what happened in this case, and how you explain that to the enterprise? Because the enterprise wants to win.
Certainly guarantee failure, and so they don't really. Some companies, the big ones, they pay, and so they don't ask for results. What they gain is they gain access to the students that do the so, and I think it's the costs are a bit like 2,000 euros per student. It's not that much at the scale of it, and some companies are really happy to pay, and they pay 2,000 is for the one that we charge, and then we use the money and we redistribute over every project. So from the beginning we say don't expect anything from us.
Please, another question. Maybe from the online? Is there any question from online attending persons or for our colleague that presented online? May I ask you a question? You mentioned about exams that are not enough, and then you presented them several possibilities of learning styles, and you had some charts about results. You had something about after pandemic. You went very quickly on it. Can you tell us, were the results better after pandemic or?
No. No.
If you can comment a little bit.
It is not. I mean, before the pandemic, their motivation was higher. I am just looking the eyes of the students. The motivation changed, and not just exams, their exams, but also projects results get lower, little bit, not high, but if I compare, as I ask you, before and after, before their studies and grades higher than after pandemic. Yeah.
My question is actually in general all the universities. So in some of the universities around the world, there are some programs called cooperation. It's based on students working or interning or doing research in the school term and using these as a credit in school, so they don't take as much classes as they would when they took classes without the cooperation. But if they apply for this co-op program, they don't have to take these classes, but on the other hand, they do research or internship or that kind of stuff. So what is your opinion in these kind of programs in general?
No opinion. So now a personal opinion for your question. It's based on the fact that we have a lot of students working during their studies. Together with Ciprian, we are in field of computer science, and you know there is a huge demand on people working in this field. Still, we do not have a formal approval of let's say learning outcomes acquired by working in the companies, but there is a possibility that they use in projects what they learn at the company. We don't have a formal approach, but they can use it. And what they learn there, what they are doing there. Sometimes they have to choose, they are allowed to choose a topic for some projects, and then they come with a topic related with what they are doing on their jobs on one side. And as a, let's say, once again, a final personal remark, I say there should be a balance in everything. So if students are forgetting about learning because they are working, it's not good. On the other side, working, it's good because they come with the perspective of their work. But everything has to have a limit on each side. That's it. I think we are very, very out of time, yes? Okay. Thank you once again very much. It was a pleasure to be here part of the presentation.
My report has some very personal and experience and very emotional experiences. I will go to speak about Student Research Societies, which is, I guess, a unique organization for research-based learning. It has 70 plus years of tradition in the Hungarian research-based learning. Moreover, I just made a fast assessment. I personally have nearly 50 years relations with this movement. I started it as a student, and I ended up as one of the national organizers of these movements. my presentation is on purpose because tomorrow there will be a proposal that we could do something similar for ELISA as well. Details will follow. So according to the Hungarian law, universities are regulated by a law approved by the parliament, and that created the most recent legal foundations of these scientific students associations. In Hungary they have the abbreviation TDK, and that is something which is well known. By law, each higher education has to have a talent management program offering extracurricular requirements and opportunities for good or interested students in all fields, science, arts, sport, and so on. So this, as I repeat, 70 years old tradition has its roots in the law. And if you think about the history, during these 70 years, quite a lot of changes happened in the politics, form of the state, everything similar. But this movement had a continuous evaluation. At the top level, the National Council of Student Research Societies is an organization which is a highly autonomous organization. It is a legal entity. It is a public benefit organization, so it can accept donations from individuals and companies, and it is in charge to organize this movement, to create a framework. In addition, this is a quite autonomous body which defines its rules and so on. I worked, and every member here with the acceptance of a small administrative office works as a volunteer. I worked here for a decade. Currently, I am chairing the ethics committee, and I remained an invited member of its presidium. So what is this about? It offers students the opportunity to perform extracurricular research helped by a tutor. That means that they focus on a problem, which is a research problem, and some tutor, a staff member, helps them in their research. It can be an individual work, but there are many cases when the students work in teams. The problem may originate in the academic interests of the tutor, some side branch of his research, or something which is, let's say, futuristic enough to spend some energy, and he finds a student. It is something like to get a highly motivated research assistant out of any project framework. Frequently, the students come to us with the question that I am interested highly in that and that problem, and I would be happy to work on it. Can you help me? Or even frequently, industry comes to us to solve something which needs research. The level of research, and that is something about which today morning a colleague of mine spoke, starts from basic research, goes up to applied research. And here there is a very tight cooperation, and we provide an intensive tutoring, while as most at the universities, we very carefully calculate workloads and try to optimize. This activity is something where workload does not count. it is a hobby, it is a motivation, and when I try to calculate some full-time equivalent, it is roughly on both sides at least twice as much as required to a master thesis, but intentionally I wrote an infinite sign. Frequently it goes up and up. So the students perform the research and in their research, small research societies, but above the research, there is a well-organized system of conferences which are competitive ones. So similarly, like at big international conferences, there are awards, and we have a two-level system. At the first level, we have institutional conferences, to which a research report should be submitted. This is roughly 20 to 60 pages long summary of their results, very similar to any academic thesis, including literature research, own results, and so on. And these reports are evaluated and scored by experts. As told, there are two levels, the institutional ones, and the best ones can go to the national conference. Institutional conferences are typically organized each year, and the national ones each second year. At both conferences, the students give a presentation, but here, in contrary to usual conferences, there is a jury, and they get scores on their performance, and I will go into details soon. It is told that the sign of this movement, which is an owl symbolizing the knowledge, science, wisdom, independent thinking, is eternal, and it is very well known in the entire higher education. So the word TDK is known to everybody independently, whether he participated or not, who was anytime a member of a higher education institution. Two little comments which indicate how far it is recognized. A few years ago, there is a, let's say, public poll for the best organization where the entire population can vote, and this movement won a prize. The second one is a very personal one. One day here in this village where I have my weekend flat, I went to the market, and suddenly an older gentleman greets me that, "Good day, professor." I wore a t-shirt with this sign on it. I look up, and this was the bishop of the region. So even the bishops know. So why is it so eternal? Why is it so popular? This kind of motivation, which is a quite free form of cooperation, the students get a very intensive and individual tutoring, the professional interests of a professor or a staff member and the student match, and they cooperate in entering unknown fields of the science. They enjoy to create new findings and so on. So that is something which even emotionally is important. In addition, the experiences of an experienced researchers are, let's say, forwarded to the student by a strong cooperation. And this leads to a very personal tutor-student relation, mostly, let's say, after the student graduates, and if he is a PhD student, he has already a very friendly relation, not only with the professor, but even with the staff members as well. They are so motivated that practically, frequently, they live their entire life at the department. So we have extra seats there, and we set up a kitchen that they can even eat during research. The next one is that they learn by doing every phase of the research methodology, starting from project design until the documentation. Such soft skills that technical report writing, publication skills, preparation for conferences are by their very nature part of the benefits. They frequently cooperate with other members of this group or even other staff members, so they get community building and education for teamwork, so-called for free. And finally, we get highly motivated people for academic and applied research. Applied research means that many of them don't continue their academic career, but typically they go to the industry, and it is well remarkable that they have a very steep career there in research and development. As told, this movement has a very high reputation, namely we grant awards and prizes, but moreover, in practically each fellowship, one for a PhD position or for some money, the results in this movement are scoring factors, and at the conferences, let's say, leading researchers from the industry are present as part of the jury or as individuals, honestly said, for headhunting. For instance, the top award, a ProScientia Golden Medal, which is granted to selected winners of the nationwide conference, are deliberated from a PhD entry exam. So they automatically get the topmost score. In the academic life, usually you don't ask a senior researcher that, did you participate in such a scientific student association, only that what was your SSA topic. Practically every leading researcher has his past in this movement. The organization is quite hierarchical. I put a simplified picture. Here it starts in this association small groups. The university faculties have a council which organizes this movement and organizes the conference. Then 16 sections collect the different branches of science. I will show it in my next slide, and organize the national conference. And the National Council, its presidium, give the framework. Basically, at each level, there is a high level of autonomy. For instance, there are uniform rules, but those are frame rules only, given by the National Council for the conferences. And each section steering committee adapts it to their specialties. All the organization maintain good relations with ministries, the Hungarian Academy of Science, scientific associations, industry, which is heavily sponsoring these events. In addition, that the base funding is by law dedicated to the state budget. Student organizations, PhD associations delegate direct representatives into it. Those are the 16 disciplines. Each of them organizes his own section for the nation.
I'm very sorry for disturbing. Can you please sum up within 2 or 3 minutes?
Please?
Can you please sum up within 2 or 3 minutes?
Yes,
Okay.
I try.
Okay, thank you.
So the workflow is the following one. At each level, 2 reviewers review the contributions, and the presentations are scored, and an evaluation leads to prizes. In this slide, I illustrated that basically the evaluation criteria are similar to the major international conferences, but all the reviews are detailed to provide a proper feedback. In order to have a feeling on the dimensions, this year we had nationwide 12,000 reports at the first level, out of which 4,500 participated at the national conference, and these are broken down according to different topics. What is an important aspect? We have a tight quality control over it, including an evaluation after the conference. After the conference, there is an online questionnaire, and I performed a small exploratory data analysis. What is the most important one? Mostly from the second year on, the student participated. They submit repeatedly reports and participate in the competition. And despite of the COVID problems, this year we held it online, and we were happy with this. The final main success indicators include that they benefit from the feedback of the jury, so we give them detailed evaluation. And the second one is that the jury looks at them like junior scientist, not a student, so the style is highly partnership. What is important more that the students are very happy. Dominantly, they want to recommend it to others, so students hire other students for this work. And my conclusion. So we have 70 years of tradition, and this movement seeks internationalization. When we will come up with a proposal for ELISA, I already asked, and the Presidium has his full moral support behind. It is extremely popular among the gifted students. It is very well recognized by the society, government bodies, scientific community, and industry. We have the well-established procedures and infrastructure, and tomorrow you will hear a proposal. What about to use this experience, infrastructure, to organize something like an EELISA Student Research Association? Thanks.
Dear Andras, thank you very much. So it was. So thank you very much for your nice presentation. So we will be taking the questions and comments at the end. So for now, we thank you. And can you hear us?
Yes.
Okay. So we will be connecting back to you soon. Okay, thank you very much.
Thanks.
Okay. So I would like to introduce the next speaker, Emmanuel Faure. So, Emmanuel, are you here?
Yes, yes. Yeah.
Okay.
Sorry.
So, no problem. So, okay, the stage is yours. Thank you.
Okay, thank you very much. Can you see the screen?
Yes, we can. But it's not in the presentation mode.
Okay, wait. Oh, let me do something. Okay. It's good. Okay. Is it okay?
Yes, it's okay. Yeah, thank you.
Okay,
Yes,
thank you very much. So thank you for the invitation. I am very sorry not to be able to be in presence in Istanbul. So I'm going to talk about experimental projects. It's a module that we have developed at ESPCI. ESPCI is part of PSL University. It's in the center of Paris. And Paul talked about another kind of engineering school in the French system. ESPCI is another one. But I think the difference is that although we are in engineering school, we are most of our students will do a PhD and are going to do some research. So the education is more fundamental or linked with industry, but more fundamentally related to research projects. And so to compare with what has been said before by Paul, the idea is basically the same, but with not engineering project, but more like research project. So let me talk about the situation and the philosophy of this course. In fact, it comes from the traditional teaching that think that try to present a complete version of science, a finished version of science, neglecting the part that went wrong, neglecting many aspects that are very interesting and that really make the way we do discovery. And so the scientific scientific background must learn how to approach this problem and how to solve this problem. And this is not the way it is done usually. So here, this led us to the building of this new modulus called experimental projects. So they are done in team also. And the basic idea of the philosophy, the main principle of this project is that the teacher should not hold the truth. Usually, when you're teaching a course, you're like God, and you have all the knowledge, and this is not the way it works in research. And this should be really dismantled in a way that the students understand that, like them, when you are in front of a new problem, then you develop you interrogate the universe, and you make hypotheses, you are wrong, etc. And the second part is you must have time. So usually you have experimental work that are related to courses. And these experimental work are usually just to check or to do some experiments that are already prepared, and you have no time to make mistake, to go and study some side effect, or just to have pleasure to probe the parameters you want to probe. So these are the main idea. So what we have developed is this experimental module that it's not associated to any theoretical course. So it's not like an experimental part of a theoretical course. So the projects are chosen in various fields. So at ESPCI we do physics, but also chemistry, also biology or transdisciplinary subjects. The topics that are proposed either by teachers, but also by other researchers or by students themselves, by anybody, in fact, that can, I mean, all the subjects that can fit with our course are okay. The group of students are 3 students, okay, so they form by affinity. Of course, the experimental projects takes place in a specific premise, which is very important, in fact, because you must leave the project so that you do not change. You can find the project from one class to another. The project, and this is really important, are systematically renewed each year. Because otherwise, you see, the teacher would have some knowledge about this that is biased. So this is the main rule. Projects are renewed each year. And each project is unique also. So this means that each year you have to find out new projects. So how do we implement this at ESPCI? There are 30 half-day sessions for a year long. Basically, it's half a day per week at the undergraduate level. The whole class at ESPCI is about 100 students. Okay, so that made about 30 projects. And the supervision, so that's their project, but there is a supervision, and so there are teachers there, about 9 teachers per session. It costs more than a normal experimental session. I would say about 50 euro per year for 100 students. And you must have some logistic, either a workshop, electronics, maybe access to a white room, clean room, or also from helps from the lab. So here are a few subjects. So you can see there can be all the kind of subjects. Some of them are really engineering subjects, but a lot of them are more fundamental research, like plants, how the plant grow, how to make, I don't know, how the dolphin are swimming, how the spider is doing his net, etc. So this kind of project. Here is what we propose typically to the students. So we show them a slide like that, and we say, okay, this is one of the subjects. So here you find on the internet a simulation of the Roche limit, which is the limit of the tidal force that destroy a planet or an asteroid that is coming in the vicinity of a bigger system. And you see, here is the simulation, here is an experiment that was done somewhere. And what we say, okay, let's build this Roche effect, and let's try to study this Roche effect with this analog system. We have, of course, some subjects that are proposed or in partnership with company, but these are a few, in fact. It's more like, again, fundamental research. Also associations. Here is an example, for instance, of a subject like bio-inspired resins that was done with a company that makes boats. And this is typically one of the subjects. The output is what we asked for the student is to do a video of their project, about 5 minutes. So you can find them on the internet site of the ESPCI. Also, we have a YouTube channel where you can find the video. There's no real, I mean, they are free to do whatever they want for the video. Here, I took 2 examples. So you see, one is a bit like a movie professional movie, and the other is like more transmission for school. And they are very imaginative, and they find out very nice way to deal with us. Also, what is very important, in addition, on the internet, you have the protocol and methods. And this is very important because there are a lot of people from outside, students or also people in high school that are looking at this video and they want to reproduce it. So you can find all the protocol and methods are given online. So here is also another way that we ask them to talk about their experiment and their project. There is a kind of experimental conference. So here you see an example with what is called the dead water experiment, where you have a wave that is between still water and salt water, and that is slowing down the boat. Okay, so that's what I want to say is, and that is very important, is from this they end up finding new things. So discovery can happen a lot of time during this project. And this is something that is new for them. They always think that you need to have a lot of money to discover something or everything has been done before. This is wrong. So here is, for example, a project. Some students studying ice skating observed that when they have the fan that is rotating, they observe colors. So we studied this for another project, and this was a discovery that we can measure the lifetime, the fluorescence lifetime of a lamp tube with this method. Another one is, it was published here, another paper that was that started in PSE, that was published in Nature last year, 2 years ago. The idea was to maintain some fluid by vibration, and this is what they observed. At the end, you can have a boat upside down, floating upside down in a fluid. So you see, this is really a discovery from simple experiments. I want to point also that it's not only discovery, it can open new fields. This is another example. So the original idea is we were trying to do non-coalescence of droplets in hydraulic jump. So you can do the experiment at home, and you see that droplets are stuck in hydraulic jump. And because we discuss, we do another experiment at the end, we end up finding that you have a new way to avoid coalescence by shaking vertically the bath. So this was an article that we published with the students, and here is a droplet. It is bouncing on the bath. Okay, so 1 millimeter in size, and if you stop the shaking, of course, it will coalesce into the bath. Then, okay, with this, we end up finding that some droplets are self-propelled, and they mimic some kind of wave particle duality in the classical world. So that was a complete discovery. And it opened the field, and now a lot of groups in the world are studying hydrodynamic quantum analog, or also time reversal. So you can use this droplet, from this droplet, you can use them to think about how to reverse time. So here, as you see, you shake some water, and by doing a shaking, the appropriate shaking, you have the waves that are coming back, like the water and reverse. So you see, these very simple experiments lead to complete, very interesting discoveries. And this is to the surprise of the students, and not anymore to my surprise, by the way. But look at this one. So this is another example. So you can also do patenting. So again, by chance, by just observation, by doing simple experiments, we were doing some Leidenfrost phenomena. So Leidenfrost phenomena is when you put some droplet on a very hot plate. And we wanted to do this on a porous medium. So look at what is going on. Up. The porous medium is moving. So it's going in Leidenfrost phenomena for the porous medium. So what you can do is, this is a patent that we deposited with the students. you can like that support some heavy object by latent phosphonol. To conclude, and there are many positive aspects of doing this. First, you have a lot of external interaction. So for the student, it's very nice. You can exchange with researchers from the inside the SPCI, but also they go outside of the SPCI and in different labs. You can collaborate with company and association, which is very nice also. It's a true training through research, which is, this is the way we should do research. I mean, we do research in our lab is by observing nature and by doing mistakes, takes time, and this is a way that we question the world. It's not what you observe in normal course, theoretical course, or where you gather all of what has been discovered by 20 years by the best people to discover this, and you say it in 1 hour like it was obvious. No, here this is really how it works. There is involvement of all the school departments, so that's very nice. Also for the institution itself. So you have all the different departments that do know that these projects are taking place and want to help, want to provide some materials, etc. There is a high commitment of the students. So for the students, it's like the chef-d'œuvre, I would say in French. So they mean that they built the masterpiece, and that's their project. It's not a simple experimental work that they need to do. It's their project, and that's very important. So that's a high motivation, and that they come even outside of the hours in the evening and the weekend just to do their experiment. It's very important for when you search for an internship, for instance, or a job interview. Of course, if you say that at ESPCI you're studying my course in optics, it's not very interesting. But now if you happen to talk about your project, then suddenly you get enthusiastic about this, and you have something to say that is different from the other, and so they use it a lot for internship, research, and job interviews. For the teacher, it's very exciting to teach, because all the experiments are renewed continuously. So every year you have a different experiment, so you learn each time new things, and that's really very exciting. The drawback is sometimes they ask you a question, and this is different from your course. They ask you a question and you don't know the answer. So you must be really modest, and they understand that you're not God. And of course, if you need to have access to this information, you show them the way you do by searching in the bibliography, etc., in the books, etc. So that's very nice for the teacher. Last point, and I think it's the main point, is that they understand that you can do discoveries everywhere around. You don't need anything, you just observe, and it takes time for them to realize that nobody has observed this before, or that has understand this before, and so that's the main message for them, is that there is something to do in our everyday life, and the discovery is here. With this, I would like to thank you for your attention.
Yeah, thank you very much, Emmanuel. It was very interesting. So we will be getting to questions at the end of this session. So thank you very much for now. So we can move to the next speaker. İmge Akçakaya waits, so the stage is yours. And we will be really grateful if you can keep your time by 15 minutes.
That's right, thank you. So this is what I'm using, right? Okay, for the next one. Hello, everyone. My name is İmge Akçakaya Wait, and I'm a lecturer at the Department of Urban and Regional Planning at E2, as we call it. So today I'll be... Okay, I can start over. Yeah, sure. Are we good now? Okay. Yes, so hi again. So today I'll be delivering an experience of a 1 year, 2 semester studio experience to you that we had with our master's students at the Urban Planning Master's Program at ITU. So I'll be taking you from the world of engineering and STEM education and research to social sciences, a little bit, which urban planning deals with mostly. And in urban planning project studios, we have a heavy design and planning component, so it's a craftsmanship too. But also, of course, we conduct our studios research-based as well. Now, what's novel about our experience is that we try to combine the RBL, research-based learning experience, with EL, which is experiential learning experience. And so I'll be delivering the outcomes of that. And I'll be narrating the whole process to you. We conducted the 2 semester studio with, the first picture is me, the second one is Professor Elif Alkay, and the third one is our teaching assistant at the time, Sinem Becerik. And because we did try a novel curriculum design from the very beginning in this process, we wanted to test our approach. Thus, we conducted a mini research with students through a survey after the end of the whole academic year. And then I'll have implications and notes to discuss all together, hopefully. Okay, so what is experiential learning? Very shortly, it is a process whereby knowledge is created through the transformation of experience. And here we're talking about not only gaining experience, but transforming it as well and interpreting the experience. Also, it's a purposeful process of engaged active learning in which the student constructs knowledge, skills, or values by means of direct experiences in real world. So we value real world contact very much, on-site research and knowledge production. And experiential learning in the literature is used synonymously with fieldwork, applied learning, learning by doing, that's the most popular one, hands-on learning, problem-based learning, and yeah. I'm trying to, yeah? Okay, there we go. It's a cyclical process, this whole experiential learning thing. So we want to achieve concrete experience, emotional experience, sensory experience on site. And then we do a lot of observation and we reflect on the observation. Observation is primary data in our social research, you know. So we encourage the students to watch, listen, observe, discuss, and understand the experiences, not only of themselves, but also of the target population that they are planning for. And then comes developing concepts of solving the problematic that they have defined on site. And then they do integrate theories, like literature-based review and research into their conceptualizations. And finally, we ask them to test their findings. This was pre-pandemic experience from 2018-19 academic year. It's a 2-semester graduate studio design, like I told you. And I will be taking you through, okay, this is the whole course program in a nutshell. I'll be walking you through this like step by step, but fast, with some visuals. Our semesters last 15 weeks with a week of break in the middle, usually. We did structure the whole academic year before we started teaching, which is a little unusual compared to like the conventional approach. We had two novel approaches in our studio design. Number one, we undertook the teaching and learning of planning studio experience from the conventional to more modern approaches. And I'm talking about the planning paradigms that we employed. So the blueprint planning, the conventional one, talks about the comprehensive planning. It's a linear process, whereas what we conducted was collaborative planning, which is a multi-stakeholder, multidisciplinary context, and also it's cyclical. So the first semester started with going to the site. It was a structured visit, and we asked the students to gather observations and primary data, and that was observations, a survey, a structured survey, and semi-structured interviews. And then they collected any secondary data they could find. And by the way, the planning problem they tackled with was about urban redevelopment experience in a Gecekondu area. Gecekondu is a Turkish word standing for the informal housing, illegal housing. And our project site was Pınar neighborhood, which is adjacent to this campus, right to the northeast of the İTÜ Maslak campus. So after the field trip, they produced like usual maps like this. We call them, analyses. They documented everything, combined the primary and secondary data. Another one about physical and natural environment of the site, and you see the borders of the neighborhood here as well. And socioeconomic analysis too. And then we asked them to carry out an extensive literature review on this new novel paradigm called collaborative planning. And we asked them to conduct a theoretical review and practical review of the literature. So they formed a repository of worldwide cases, not necessarily good practices, but best practices and then less good practices. And they reviewed them and gave seminars in the studio for knowledge sharing. Then they conducted a stakeholder and actor analysis. They worked in 5 groups, by the way. There were a total of 25 students in the studio. And some of them were international students, a couple Erasmus exchange students. And the language of conduct was English, by the way. So, pretty complex processes. We had to move very fast. When we met at the studio in person, they shared all their findings and their models in class, and then they received feedback from each other, the 5 groups, and from us through desk criticisms, and then they continued and deepened their research, so that was the idea. We held jury assessments. That's a very traditional approach to studio teaching and learning. We usually have some guests from local actors, stakeholders of the planning problematic. So we had one jury assessment after the analysis process. Are you moving it? Should I not use this at all? Okay, I'll just put it down. Thank you, that's easier. Okay. And then another round of extensive literature review, this time deepening in the collaborative planning paradigm, which was followed by further analysis of the project topic and site, followed by synthesis of data and analyses that they conducted. Yeah. Yeah, we asked them, you know, collaboration is all good and dandy, but then there are many risks associated with it. So they did research and some evaluations on possible conflicts and their mediation tactics and strategies that could be associated with them. So they engaged them in their planning, collaborative plans. So they produced physical planning work as well. Yeah, we can just continue these. And then it was a cyclical process in that they received crits and then they went back, they deepened their research and then reflected back, and then, you know, time and time again, criticisms. We held a final jury at the end of the fall semester. The project 2, spring semester, started with a review of the previous semester's total work. In the cohort, the student group, there were some changes, you know, new enrollments. So we gave them a little bit of time to adjust, adapt to the context of the studio. And they did go back to the site for further analysis, any data that was missing, that they were now interested in, you know, because the research continues and expands. And they did refine their analysis and synthesis work as well. They carried out more observation, more interviews with new questions this time. All right. And they refined their physical, socioeconomic, financial plans and models, and collaborative planning models as well. More literature review on collaborative plans from around the world, theory and practice focused again, and they adapted their secondary findings into their primary research and plans. We can continue. Yeah, a repository of world cases again. They designed the process, not only the plan, but the process of the collaborative plans in phases. And then we switched to the real context, the main context of the spring semester, which was collaborative governance model. So here's a novel approach that we employed in this process. Could we? Yeah, they did another review, this time on collaborative governance models in the world. And then we gave them this. This is a cumulative collaborative governance model that was produced by Ansel and Gash of reviewing 137 collaborative governance cases from around the world. So this is a cumulative model, like I said. And we asked the students to adapt this model to their case study. And the outcomes were exciting. Yeah, this is one example, and then another one. This is another one. So once they had these models, we asked them to test their models, and we provided them with multiple methods, tools to do this. They conducted a risk management analysis, like possible conflicts and their mediation, like I mentioned a little ago. And then they did conduct a focus group study on site with local actors, stakeholders. This is the second novel approach in the curriculum design. And then from the literature, again, they derived the good governance principles and questioned the existence and the operationalization of these criteria in their model. And they did some legislation, law and regulation review too, to see how applicable, implementable their models were in real life in Turkey, in Istanbul. And then all the while, you know, they received desk crits, and we continued to have juries. This is a meta RBL approach, I think. The students were really excited to have this focus group workshop in studio. They had not conducted a focus group study before, and we taught them how to do it, you know, through a workshop. And if we can move on to the next one. Yeah, so a few photos from that day and my presentation. We gave them all the technicality of how to collect data through focus group study and analyze data and incorporate their findings in their models. And they did conduct this focus group with local stakeholders on site. We used the district municipalities building, an on-site location we picked. And it was a lovely day, very exciting from the students' point of view in particular. Then they came back to the studio and analyzed the data they collected, and then, like I said, incorporated them in their collaborative governance models and collaborative plans. Sure, yeah. So we're getting, if we can move on, thank you. So analyses, yeah, we can just move on, all right. And the final steps was, again, testing their collaborative governance models through literature review again, and then, these are the refined models this time. And we closed off the whole academic year with a final jury with participation of local stakeholders. After the year was over, we had such a good synergy, the university and our local actors, that they asked for a symposium to disseminate the students' works to the public. So we did that through a symposium, a little colloquium. Yeah, we can just move on now, yeah, this is us. And then, okay, yeah, this is the poster of our colloquium. 5 student groups presented their work one by one, and then there was a lively discussion afterwards. And then, like I told you, we conducted a student survey to test if our new approach worked well or not. Group means comparisons from a scale of -2 to 2, which shows that here we compared their undergraduate conventional planning studio experience with our more contemporary master's planning studio experience. And in all categories, their graduate studio experience surpassed, was better than their undergraduate experience. And project 2, with this real life, more RBL-focused project 2, was liked better than project 1 by the students. Group mean correlations, let's just skip this one, because we don't have time. Before and after, from the experiential learning point of view, case studios, in the case studios that we conducted, we had EL principles and RBL EL methods more heavily embedded in our studio design. And that was apparent with the findings of our survey results, the survey with students. We reflected back on the literature of, teaching, pedagogical literature on experiential learning. And we found that understanding and articulating the importance of practicum course clearly was very important. Designing the whole process in the beginning is important, and defining what to expect, the learning outcomes in the very beginning, both by faculty and also by students in the beginning, telling them what to expect from the whole process. We need a clear syllabus, course plan, outlined to the students, and a careful site selection, because they may not collaborate as we expect them to. So we were careful with setting like a nice collaboration base with the local municipality and the local community in the very beginning to ensure a smooth process of research. Good client relationships is a part of what I just said. We don't like really using the word client, but we like, they're like different actors on site. And we had the students work a lot, so we were easy on them at times, and we wanted to increase their motivation as much as we could. So an open dialogue was important to increase their participation in the course. This is our model summary. The paradigm shift from conventional to contemporary planning as an urban planning approach. Continuous literature-driven research in both theory and practice, as you saw. Site selection is important, I said, like frequent site visits for the real-life observation conduct of the studio. The Meta RBL experience, which was the focus group workshop I told you about. That we had thematic primary data gathering and analysis methods. We used so many qualitative methods to conduct our studio, so the students experienced them time and time again. Secondary research and model adaptation, the collaborative governance model that I told you about. So they adapted that into their work and then readapted with feedback from the locality. And multi-stakeholder collaboration, decision-making, and assessment. So that was one main outcome, from this whole process. On the EL side, these are the primary principles of EL, experiential learning from literature. We believe, and our student survey showed that we did targets and we achieved these principles more or less. Urban planning is, with the rise of urbanization all over the world, is getting more and more complex. So with real-life experiences, we need novel approaches to teaching planning in our planning and design studios. So that was the main drive. The conventional approaches do not work as effectively anymore. And we should focus on the means of the whole planning process, not the ends, just as the archaic teaching methods tell us. And we also designed the studio to be inclusive, actively involved both students and local actors, and that had greater benefits on students' motivation, comprehension, and solution generation skills in general. Last two slides, we were lucky to disseminate the outcomes of our this whole experience, teaching and learning experience, in a congress of Association of European Planning Schools in Venice in 2019, and also as a book chapter that focused on the post-education research findings. So I will be happy to share with you these outcomes, these publications, if you're interested. Thank you very much, and I'm sorry for getting over my time for a little bit.
It's okay. Thank you very much. Thank you. So I just need to pass to Simona immediately. So now Simona Galerani will be presenting One Day as a Researcher. So the stage is yours.
Maybe wrapping up in about 10 minutes?
In 10 minutes?
Yeah, because we leave at 7 for the social program.
So maybe not 10, but hopefully we can manage in 20 minutes. Will that be okay?
Too late. By the time we leave here, maybe 50.
Okay, let's make it. So Simona, I will ask you to finish in 5 minutes. I'm really sorry for that.
Okay, I will do my best. Okay, so my name is Simona Gallerani, and I'm a physicist. I'm teaching the courses of astrophysics and astrobiology at Scuola Normale Superiore. And today I would like to present maybe a couple of initiatives that I think that could be interesting to be shared in the context of a research-based learning symposium, above all for what concerns STEM education. So I will start with an event that gives the title to my talk, One Day as a Researcher. As an astrophysicist, I've been always asked, how do you spend your day? Are you always spending your night looking at the sky? Do you have a telescope in your office? So questions like these. The event, One Day as a Researcher, has the goal of trying to reply to these kind of questions. In particular, what does it mean being a researcher? How does a researcher spend his daily working day, and what are the difficulties and challenges from one side, and the successes and rewards in the life of a researcher on the other side. So how this event works, basically the SNS opens a call for students from the secondary schools, and interested students can send a short article about a scientific news of particular interest. So the goal is to trigger interest in scientific topics and also to let understand students the importance of supporting arguments with verified sources. We have a dedicated committee of experts in different fields that reads the work of the students and select the best article for each discipline. So I was reading articles about astrophysics, of course, and here is just an example of the press review that we received from students of the secondary school. Most of the topics were about black holes, about quantum gravity, also life in the space, comets, solar system, a lot of topic about astrophysics. I'm going very fast, I'm sorry. At the end, we have to select like 5 to 10 students, and here you can see some pictures taken during the award ceremony. So we just host the student, and we give them the opportunity to follow step by step an SNS researcher or a group of researchers during their working day, and they can participate to all the daily activities. They can share in the reading of articles, they can share in the development of, for example, cosmological simulations, and of course also share the breaks, the canteens, and so on. This kind of events has been then extended to what I'm calling 1 week as a researcher. It is about integrated schoolwork linked training. So this is the pretty dense agenda that we prepare for them. So the idea is just to give a first overview about the history of the universe, and also to let them know about some coding, like for example through Python, we were teaching what is a black body spectrum, how does it change with temperature, that is particularly relevant for the history of the universe. Then of course we enter a little bit more into the physics, even more into the physics. So what is a star, how we get to a star, so the gravitational collapse, and they are expected to write a report in LaTeX so that they can already understand something about how to write a scientific paper. Then we went through observations of high redshift black holes, of high redshift galaxies, and they can play with some data that were collected by our group. Here you can see just an example of one of the most distant quasars discovered so far. After that, if you can start the movie, After that, so from observation, we pass to theoretical models, and here you are witnessing the birth of one of the first galaxies that we simulated in our cosmological box. So the idea was just to let students understand that we start from what we observe, but then we have to complement our observations with the theoretical models in order to extract at best the properties of the universe. And finally, there was some time spent on galactic habitable zone. So what are the region in our Milky Way galaxies in which we can search for extraterrestrial intelligence? And also in this case, we were trying also to provide some tools that then can be used, apart if they become an astrophysicist or not. And in particular, for what concerned this section, we were focusing on machine learning. Maybe this is a success story in the sense that while I was preparing this talk, I contacted one of the students and I was asking, so what are you doing right now? And I was very happy to know that he was doing a master in quantum universe at the Groningen University. I don't know if it is a success story because I didn't ask him if it was happy, but surely he was inspired from the experience. Why I'm saying this? Because I would like to expand these kind of initiatives in ELISA. So what I'm calling is 1 quarter as a researcher. What I'm proposing in the ELISA consortium is a project that is called GATE, and it stands for Graduates Academic Training Experience. So the idea is to have bachelor students that they can spend a quarter in one of the ELISA university, and this is basically the task of work package 5 in ELISA. So what we are trying to do is to coordinate graduate students' research internship in an international research laboratory. And before concluding, I would just like to mention another initiative that is called ISPIRA. And the acronym stands for Inclusiveness in Sciences, a possibility of identification and representation for women. So this is just to try to fill the gender gap. The idea is to have outreach in schools this time, and the idea is that these speeches are given by PhD female students, just to offer young girls the possibility of identification in the researchers, and also to provide evidence for young motivated women in STEM. What is the very original part of the project is that we train the PhD student with a theater workshop. So there is a project, it's called the Atomic World, and the idea is that they have to rediscover the art of telling that is especially important when you want to talk about complex concepts as it can be physics and astrophysics. Again, the ISPIRA project, I'm very proud of it, has been completely conceived and developed by PhD students. So the SNS is just supporting this kind of initiatives, but the ideas are really coming from the PhD students. And so I will be very happy to discuss in the next WP5 meeting how we can inspire our GATE project in ELISA. And I just stop here. I did my best to be very short.
You were great. Yeah, thank you very much. You were really great. Thank you very much. Okay, so we can continue with Alistar, Andrea. Okay, so the stage is yours, and again, we will be grateful if you can keep.
I don't need more. 5 minutes. If I have the. Okay, thank you. Okay. Good day, everyone. Greetings from University Polytechnica of. Maybe we can switch them. Let's try again. So, greetings from University Polytechnica of Bucharest, Romania. I'm Andrea. I'm a PhD university student in computer science. And today I would like to present to you how to make open science easier and exchange knowledge For example, you saw that in the previous presentations, they were talking about their successful recipe of using various learning techniques, but all of them had a common ingredient, commitment. So I would like to present you what we did using commitment. It's called Crescedi. It's actually a research data management platform used in our university. Okay. The motivation behind of it is quite simple. We didn't have a centralized environment to store all the researchers' data. So we try to implement one using existing external sources like Google Scholar, Clarivate, Scopus, DBLP, and many more. We wanted to aggregate all the data retrieved from two resources in our common deposit called Crescedi, in order to help our researchers to prefill different forms, to share the knowledge, and of course to help them to make visible their research activity, to spend less time to complete different forms, and also to help our university to gather different metrics for their publications, patents, and many more metrics. As an overview, we already started this project in 2018. So we started with baby steps to collect the data and to have some trust platforms from where we can retrieve the data. In the end, at the moment we are here, the university is already using this platform. We have a lot of data already aggregated in it. The feedback received is quite good. We are planning to develop more features for them. The technology stack used, we are using the bleeding edge, the latest ones. It was actually created to be used by other universities as well. And we are dedicated to implement many more. As future research directions, our platform has the provides the possibility to gather different metrics for researchers. But we would like, for example, to add some labels at the departments or faculties level. For example, to know in which area a different researcher is actually publishing more. So in the near future, we will try this approach too. And as conclusion, we do have a short video with our platform. Maybe it's more powerful than words and phrases. So I invite you to take a look. And that was it. And also, if you are curious, you can actually check our platform. It's in the header. You don't need to have an account. You can check the researcher's activity. Of course, you won't be able to see some internal stuff, which is normal. But if you're curious, you can go there. That was it. Thank you.
Thank you very much. You are also great. So, okay, thank you very much. So we can skip to our last talk. I would like to introduce Fatma Yavuz and Güncel Gürsel Artıktay. So the stage is yours, and again, I have to ask to keep it short.
My presentation is short, but I will keep it as short as possible.
Hello, my name is Fatma Yavuz. I am a librarian. I think I am only one librarian in the symposium. I will talk about information literacy and information literacy application in Mustafa İnan Library. If you ask what is information literacy, the traditional definition of illiteracy was the ability to read and write at the basic level and sign a document. Information literacy has four core elements. These are technology, synthesized communication, problem solving, and thinking. And also information literacy has some standards. These standards are created by Association for College and Research Library. I am passing these 5 standards. And also information literacy is important for research area because information and learning based on these 4 parts. When you look at hierarchy, these are data, information, knowledge, and wisdom. Data includes individual facts, some statistic information is organized, structured, and categorized, useful and condensed, calculated things. Knowledge is idea, learning, and notation, as you see. Wisdom is understanding, integration, and applied reflection upon these kind of things. Information literacy is important because it's a form, a kind of form lifelong learning, and it's common to all disciplines, all learning environments, and all level of education. I want to talk about application in Mustafa İnan Library. As you see, this is our web page. So we describe database types and their function. So how can students use research methods? For example, we talk about using Boolean operators, using truncation. How can they choose keywords while searching? And how can search subjects? So we describe these things, and we describe databases, technical and other functional features. So we have over 100 databases. Some of them from index databases, Scopus, Web of Science, to multidisciplinary databases, Wiley, French, and Taylor, and Mendeley reference manager databases. We talk about them, and also plagiarism detection databases. And we are preparing some tests, as you see in the results. With pre-test, we are using Kahoot application. With pre-test, we are measuring students' information level needed. So we prepare questions, and with post-test results, we aim to benefit of information literacy training is measured with the post-test. We ask here 22 questions to PhD students. Generally, we took good feedbacks, and every year and every semester we are repeating these trainings to students. Thank you. Now I am giving the word.
Thank you. Thank you. So, please go ahead.
Okay, thank you.
And first of all, I want to introduce myself. I'm research assistant of ETU Graduate School, and I'm working on musicology and music theory. First of all, I would like to talk about the application that is applied to the ETU Graduate School. In this way, it may be possible to better understand this presentation. Scientific research, ethics, and seminar courses are given commonly and online by the ETU İstanbul Teknik Üniversitesi Graduate School to students of all departments. Only the first week and the last 3 weeks, the student conducts the course with his or her advisor. In the remaining weeks, lecturers who are experts in their fields make presentation to students on various academic topics such as ethics, research techniques, and publication process and rules. So I'm the research assistant to these courses. The next slide, please. Yes. Within these weeks, the lesson themed research-based learning was held by Mustafa İnan Library. This is exactly the main topic of my presentation, both as a student attending these courses and as a research assistant. As known, research process involve many difficulties and uncertainties in terms of both accessing the necessary resources for the study and using these resources. It's very important to be informed comprehensively and consistently on these issues, which are essential for research. A student trying to produce an academic product mostly learns to or tries to learn this information in the process while doing his her research. Worse still, unfortunately, they learns by necessity after they get into the trouble. In this regard, presentation on topics such as research process management, information literacy, information literacy, use of resources, and legal and ethical issues were made by Mustafa İnan Library as part of scientific research, ethics, and seminar course. And next slide, please. Within these presentations, students were informed about information search techniques, types of information sources, and use of catalogs and databases, and legal and ethical issues related to the use of these resources. As part of the scientific research, ethics and seminar course, we organize a feedback survey from the students in order to expand and improve the lesson contents. These presentations were among the presentation that received the most votes from the students in terms of efficiency, and it was asked to continue by majority of students. And the most important points of this, they explained the reason for this decision as providing practically useful information and clarifying their knowledge about the research process. As a result, while this practical and necessary information for the research enables the student to have a clearer idea about the research subject, and it's also made the research process easier technically. Providing such information continuously and consistently will make it more attractive for students to conduct research in the academy, and will also contribute to solution of the possible methods problems. And that's basically all I have to say. Thank you.
Thank you very much. So also, okay. Thank you very much. So I would like to close this session. I'm really sorry not to be able to get the questions, but what we can do is I think we can discuss during the dinner. And please feel free to ask or email your questions to Emmanuel or Andras. So I think this will be the best option for today. So thank you very much for your contribution, and I'm grateful for all the speakers. So they made a great presentations. So thank you very much. Okay.
I also put a picture here of the Bologna system because when I did my university, it was not used in Hungary. So we could just start doing research at very late years in our university, let's say 4th or 5th year. But now, because of these cycles and because of that the students have opportunity to do some project even in earlier phases, they can even join to the research at the bachelor level. And I guess that's quite important because that really opens up the opportunities to participate in these competitions. And okay, so I'm a big advocate of this Scientific Students Association because in my experience that most of those students that participated in these competitions, they also started doing a PhD a couple of years later. So it's a really good indication of somebody willing to do quality research. And students used to do it after 1 or 2 years of active researching, and they write a paper about it and they present it. So because in the former presentation we heard that soft skills are quite important, this is a good forum at our university to improve all these soft skills. So we teach students how to write scientifically and how to present scientifically. So it is quite useful for them, and I guess it's a very good idea at our university that I want to spread all around in the project. And actually, at the next level, where we do different validations, we try to develop with the students nice demonstrators just to make the research fun. So here you can see many demonstrators that were developed at our department. We had a railway system, for example, that was actually in itself participated in the Eclipse Open IoT Challenge, and it won 3rd place, and it was completely developed by our students. And also students developed, for example, virtual environments to test artificial intelligence and autonomous systems. So doing all this kind of lab activity, I guess, that makes research fun, and it is really important. And that was our main motivation, to have so many demonstrators. And I must also admit that many of these demonstrators just reached such a high level that were used even in European Union projects as demonstrators. So it is quite easy to work with motivated students. And then comes also the first international publications. We used to target small venues at first just to have some success, because when we tried, let's say, very big venues that can, well, people can easily reject it, and that's not good, I guess, for early stage researcher to get all the time rejected. So, for example, all those demonstrators that you could see, they were just presented in various venues. And then, at the higher technology readiness level, we used to involve industrial partners. Students used to be involved in European Union projects. And this is the phase where one can think about if it is worth doing a spin-off company or something like that. So you have to evaluate if your idea and what you're working on worth, for example, spin-off companies. And I can tell that because many, actually at our research group in the last 15 years, 3 spin-off companies rose, and actually one of them works with not just Hungarian, but European and also many companies with the USA. So what they reached is a very, very high level of competence. And actually, this is the level which is usually targeted by PhD or postdoc at the postdoc level. So this is where you can really think about the industrial application. But it's still very important to have this line with the students, because if they know that you can reach, for example, really industrial usage of your work, that really motivates students. And actually, even if a project is not continued, so if it is not worth doing a spin-off from it, then many of our students can use their knowledge in top companies such as Facebook, Google, as I mentioned formerly. And when I was traveling here, I just met at the airport one of my ex-students. And I just told him that, okay, I'm coming here and we are just talking about research-based learning. And he mentioned me that for him, it was when he went to a company, he couldn't use exactly that knowledge and that developments that he did at the university. But he told me that when he went to the company, he really understood the concept and the research thinking and the importance of research thinking that we taught him. So I think it's a very important takeaway that even if you don't do it in your own company, then what you learned will really help you in real life. And actually that's a very, very important takeaway. So thank you very much. I hope you found some interesting ideas, and if you have any questions, I will be here and I'm happy to answer them.
Thank you very much, András. I think it was an excellent demonstration of the lifelong research and learning project of our informatics faculty. Our next speaker is Aguzsán Györlő from the host university. Title of his presentation is Mutually Beneficial Undergraduate Student Research Activities for Fundamental Science.
Thank you. Welcome to ITU. So I think I'll be the first presenter of ITU today in this session. After the technical problems are solved, I will commence. As you know, it's like the Microsoft demonstration. If you want to do something in a technical environment, the technical stuff doesn't work. So that's normal. It's very small. Okay, good. So, okay, first off, let me thank the organizers of this ELISA project, actually in general. And finally giving me the chance to understand actually what I've been doing in the last 14 years. I now know what I'm doing. because I learned a concept. It is called research-based learning, RBL. I had no idea until 2 months ago. And this was something I've been doing since 14 years, apparently. So my presentation will be mostly about my personal experience at ITU after moving back to Europe to here, about 14, 15 years ago. So by just looking briefly, I hope this works. Yes, that was me or you? Let me try one more. Okay, so I will tell you what NanoBees is actually. So what we've been doing at NanoBees in the past, I don't know, since 2008. And how, why, when, why on earth I just decided to give such a name and then generate something like this. And please bear in mind that I'm a physicist. I'm not an engineer, and I'm generally not good with engineers. So I have to accept that. So sorry about that. Because I have nothing to do with application. I don't care about the application of the information I produce, but it's open to everyone. If you invent something, it's just free. I don't care about patents and all that stuff. Sorry about that, because I'm a scientist. I will try to give you a case study. As I said, this will be my personal experience, so I had to pick out of zillions of experiences in the past 14 years, of course, and I just choose one. I'll try to talk about that. And then try to give you a brief idea about the benefits, actually, of this to the students, to the environment, to the community, to the world, and all that stuff. And I will try to tell you also how we try to keep this environment alive, which is not working lately, but you'll see. And I will summarize. So please, when I do this, please do this. Okay, so what's NanoBees? Actually, it's my research group. It's the Nanoscale Surface Science Research Group at the Physics Department. But why on earth we had the idea of converting this to an undergraduate research environment, which also, okay, I'll just give up with this one, so please do this one. Okay. Okay, I moved back to Turkey back in the end of 2007, and we had, I think we still have a very bad habit in Turkey. We have no startup funds. And especially if you move to an engineering university, nobody cares about fundamental science. So you have to really figure out how to survive. So not do something, just first to survive. So I started looking around, and then, okay, this is a huge university. There are lots of facilities. Istanbul is actually a huge campus. There are about 3 million students, more than 53 universities at the moment. So it's a huge, it's bigger than the country. It's bigger than most of the countries. So I looked around and tried to find some form of support while I was writing project funds to start up the group. But then I realized one thing, which was terrible. Not much has changed, because I started at the university in 1994. Unfortunately, nothing was changed with the physics education. It was the same almost 200 years. This is really bad. Actually, this is pathetic. Because in physics, students have to wait at least 2 years to start studying physics. We feed them whatever they had in the past 12 years, and then we expect them to be good scientists and actually good people. Actually, we expect them to survive. So, given the fact that we make them wait, feed them questions, feed them homeworks, feed them heaps of whatever they don't like, that they don't expect, then I started talking around with many students, and of course the expectation of the students changed humongously because of the technology as well. Because the YouTube was not that YouTube back in 2008, but now you know what we have as an online education. The COVID taught us a lot and all that. So the whole landscape of students have changed. Please. And I said, okay, I was constructing anyways. One more time, please. I was literally constructing, by the way. I was constructing halls, walls, doors. You're welcome to visit my labs. When you're here, it's just next to here. It's just 50 minutes from this building. And I want to show the students how to start real research from bottom up, literally bottom up. Then, next. And then I had the big chance. We organized in 2008 a conference. It's called NanoTR. It was NanoTR 4. There were more than 1,000 contributions to that conference, actually. And we organized that with undergrad students and some master and PhD students. And I've seen how students can be motivated when you show them, actually, the end result of an international community. So there, but then of course students do not expect you to show them how to dig a hole or build a wall or just how to organize a conference like these guys are doing over here at the moment probably. So they expect more, please. And with a very limited budget, with my own resources, so I'm proud to say I spent a quite serious amount of money from my pocket actually to those labs. And I got a student STM and had this brilliant idea, I think, which worked, to teach first year and even high school students quantum mechanics by doing. Because quantum mechanics is really non-intuitive. It doesn't exist in your life. But if you show the students how it works in real life, then in principle, they can start to learn themselves. So that's how Nanobi started in 2008, actually. And this is my case study. So it's about seeing. So everybody knows what a microscope is. Everybody knows what seeing is. But when you tell them that actually there's a quantum mechanical way of seeing, things change. They start questioning. Like for not many people maybe know what an STM is, but basically, if you have a surface with atoms and if you have a very sharp tip, one more time, and if you just move this tip on the surface, you can actually measure the tunneling current between two electrodes. This is really cool to show to a high school student. Even now I'm actually teaching this even to primary school students. Because you tell them that there's a wall, you have a ball, you throw the ball to the ball and it passes through. That's the same with the electrons. Then of course this is theory. Next. And then if you treat this as a blind man's stick, you can raster the surface and then make some form of a map for a surface. And then you can show them something very common, which is graphite, carbon. And you can image the carbon surface, next please, and you can tell them, hey guys, look, this is a single carbon atom, which I can see on this table. You can imagine the motivation they get. So you can show the students atoms on the surface. But this is not, of course, enough. You have to relate this to much bigger structures, like you probably see in our door. That's the ITU door. So we have this honeycomb lattice. And if you have two patterns, and you rotate them with respect to each other, you generate something called Moire patterns. Then you can just actually model this very nicely. If the doors, this precise angle was 15 degrees of rotation. So these are these famous graphene layers. If you show to the student, guys, look, these are two thin sheets of carbon. You put them on top of each other, you rotate them, and you put them under your quantum microscope, and you not only see the carbon atoms, but you also see the Moire patterns. Then this changes their life, because that's optical, this is quantum mechanical. Then, of course, this way, you can start introducing the end result of quantum mechanics to any level of students. They don't need to know even about mathematics. All they just need to have seen so far is just a simple microscope. Then treat them as adults and then tell them, okay, so this is a new type of microscopes and so forth. And for the students, of course, they start questioning, because the first year student, what are they exposed to? They're exposed to basic mechanics, electromagnetics, which they've been seeing maybe for 3 years in their high school years. So you can push them, look guys, there's now a new thing. These are called differential equations, and there are waves, and you have to treat them. And then it's amazing. It was my experience in the past 10 years that students just go to the library, find the differential equations book, and already start learning differential equations in the second month of their undergrad, instead of waiting 2 more years. Then of course, okay, this is an engineering school. I told you that engineers don't like me too much, but there are lots of engineering problems to solve these and make this microscope, like vibration isolation, measuring very small currents, making new materials to move stuff. And then they start imagining how to improve this. And then I had lots of students who started already building these instruments as well. And then this can motivate them humongously in their already first year. So continue, please. And this is novel materials, basic physics. And so showing them actually a new direction. So as I said, I'm talking mostly about the physics students, but there's a sad fact that we tell them why to study physics, please. This is a fact. Unfortunately, at least in our country, at least in this university, when students come to a physics department, they realize very late what they are doing or what a physics department is. You have to tell them, actually, as early as possible, what a physicist can do and what type of fields that they can distribute themselves, and then just learn, contribute, and all that stuff. And of course, over these 14 years, I invented many more than, I think, 35 packages to treat the students or give them as undergrad projects already as a first-year student. And then they can work on their own projects, please. So, what are the benefits? Because that was the main title of my talk, of course. So what are the mutual benefits? I have a huge list, but I'm going to talk only, it's much longer than this. I picked some. One important thing, I think, this is my personal idea, is awareness. Because, okay, I feel getting old when I say this, but I don't know, probably you also realize the level of awareness in the societies is really going rocket bottom. So you have to tell to the students how to be aware about their surroundings, starting from their classroom, from laboratory, from the society scale. So putting them into a laboratory or just giving them a chance to work in a lab, treating them like researchers actually, and then telling them, okay, you're on the way to do research and also science, and give them the chance to combine theory and practice, it increases their awareness, their negotiation skills, and one more important thing, their questioning skills of the scientific literature. Because we all know scientific literature is 95% junk these days. It's very difficult to identify from reality, and just shiny, nice nature science type of publications would mean nothing. But they have to start this as early as possible. So that's one of the biggest advantages, increasing awareness and then doing this. And furthermore, we of course made a rule book out of 14. This is a huge experience because I had more than 150 students, maybe 200 students over the course of years. My first rule, this is my personal idea, but I can defend this for days. And then I don't think there's anyone on earth that can break this down. Rule 0, do not select students. This is the worst thing our academia does, to my idea, to my view these days. We pick students, we wait, we look at their GPAs, and then we pick the best ones. What's the point of being a university academician if you're picking already? Because that's what I experienced as well. In our country, we have a very harsh system of university entrance exam. So 3 years of very young people are demolished from age of 15 till 18 to study for this exam. 3 million students take this exam every year, and only 50,000 of them have a chance in life. Sorry, that sucks. And if you take these students, we get some of the best students actually in Turkey. If we start ranking them and then selecting them based on their grades, that's again horrible. So that's why, don't select, don't rank, don't put students into a race. Just let them and give them an environment so that they can work and live together with as many as people, and then create the necessary means for continuous interaction of the environment. So with using whatever online tools are available, whatever local tools and international tools are available, and finally, of course, make a general rule book for people to work with. It's like the constitution of the lab, which is always open, which is extendable. So based on these ones, what's the methodology to run such a group? Let me just share with you my experience, so maybe this will help you with certain things. Next, please. So there are steps. So how does one start at none of these? First, they either come find me, or they just hear it from people, or they take my class or somebody else's class, and then I just say, yeah, okay, come. I'll tell you what we're doing. So first, there's the general interaction. But after the third year, actually, this know-how developed, and actually we have a soul of the group now, that I let students talk to students. They have to tell them what they do, what are the difficulties, what they like, what they hate, what they suffer. So that's the important second step. After 2 and 3 months, they choose either to be in the group or not, and then they spend some additional 3 months with one of the groups, subgroups which I have, and then they continue there. And then one thing they have to watch for, this continuity, because they have to come to the lab at least 2 days and minimum 10 hours per week. Otherwise, there will be no continuous interaction. But they have to watch their courses, of course, because that's the most important thing these days. Because when they apply somewhere, everybody takes a look at their GPA and then selects people like they are berry picking. So then they have to join all the meetings. But most importantly, next, please. Everyone writes a very short report weekly. On Sunday at 5, I receive a short report from every student, no matter how many they are. They write only 3 or 4 lines. One, what they were planning, what they did, and what they'll be doing weekly. So this way, after 3 or 4 months, they look at their reports and they see how they progress. I actually let them, and then they of course share it with the rest of the group, so everybody knows what everybody else is doing. And they have to read at least one paper. Then there's also, of course, the detailed report writing, and then monthly presentation with 4 subgroups has to be done. Then I follow there can be also side random progress talks, but that's very critical. We have lots of Google calendars, but the most important one is everybody sees everybody else's calendar, but there's one calendar which says who is at the lab. So this has to be also updated weekly, at Sunday, at 5. So then that week everybody knows who is where. So this keeps the continuity. And then they have to keep me informed. This is the really most time-consuming part because I have to make myself continuously available. And then this creates a continuous information exchange. And then, of course, these are the two crucial things of any lab or any research group. Everybody has to have some basic assignment, like taking care of the coffee money, buying the water, or just cleaning, or we also have those duties. And then they have to keep to the rule book. And after the 5th month, most of the time, the students who survive, because it's really a survival game as well. I see some of my students back there. And then they continue. And then, how it continues, that's the last step actually. The ones who decide to continue, when they generally come to year either second half of the 2nd year or the beginning of the 3rd year, they decide on a graduation project. And I don't let students make a graduation project in only 1 year. They spend at least 2.5 years for that graduation project. And then, in the end, after their 4th year, if they decide to continue, we write a research project for them. We get the funding from TÜBİTAK or other agencies and try to support them for a master's. So next, please. But one pretty important thing. Next, please. This helps a lot. Bringing students to a large international conference, undergrad students. And we could do this. The record was, I think we had 15 presentations in the DPG March meeting in Berlin once. So 12 undergrad students were there, and all of them are now in abroad. I'll show you which institutes they're in, and they are in research actually, because they've seen what they where they are ending up, what they want to do or what they not to do. But unfortunately, we cannot even go to non-OTR anymore. Simple economical reasons. Next, please. Now, difficulties, of course, I have to tell this as well. Requires a lot of time. Clear. I stopped publishing papers. Okay, I published 1 or 2 every year, but forget about publishing papers if you're going to spend so much time with so many students. But then your end result, actually, you're publishing students, not papers. Of course, the money issue there. You could just, I'm really juggling around lots of different funds, supporters. So this is about to end, unfortunately, again, because of economic crisis. But we have a new support from the TÜBİTAK Methodology Institute and some private donations, which we can run the labs. Next, please. Almost at the end. And this red one, it's really killing me. But now I learned not to listen, because when you, after the end of 2 or 3 years, if you spend so much time with undergrad students, your colleagues kill you. They just tell you, why are you spending so much time with undergrads? Yes, because I'm not at Max Planck Institute or CNRS or somewhere else. I am at a university. My job is to educate the next generation of scientists because I'm a physicist. Very rarely this is understood, especially in this university. Sorry about that. So next. And what are the benefits to the students? That's the second part. So they learn what they like or dislike. And they have a chance to try academia during their summer study periods as well as their summer study stories. So they can pick between industrial academia. They see the international environment, they make colleagues. And now I had more than 150 students in the past 12 years. And currently the group is about 18 people. Now there are 14 on the going, and our former students are in these places. We really made a good track record actually in 14 years. It took an effort, but we have everyone from Princeton to Harvard to Yale to ETH. Some of them are already in institutes, companies like Google, whatever. But it was really a result of the starting of the nanobees. Next, please. And what is the benefit? Because there was the mutual benefit part. At the start, of course, you know, this old type of cars, you had to really roll the machine to run. So that's what I did. Now, actually, the students are running it. When they need something, they come up with a question, then another group comes with a solution. All I have to do is, okay, come together, find the funding, support them, and then we actually literally built the lab from scratch. Really, you're welcome to see the labs, because if you want to see labs which are really constructed by undergrad students, I have 3 of them, just next to here. So, and of course, some of them generated international collaborations. That was the fun part, because when you go to a conference, the students, you know, how amazing can they think, and they attract interest of international scientists, and then this is about to finish. So, next one. So, summary. I have only one summary actually. I didn't create a research group, but what I call is I create an undergrad researcher group. So this group works, runs, and it's still running. And I hope that I've shown to my colleagues and in many places, also globally, that it's more important to publish people than publishing papers, because the world needs good people these days, and especially in the environment that we live. So with this, thank you for your attention.
Thank you. Thank you.
I love this presentation, but and I'm sure that everybody has questions to the professor, but we have to keep our time. So the floor is yours. Sorry. We have one colleague from Italy, Franco Ligabue, sorry. The presentation will be about not just frontal, the importance of a multifaceted approach to science teaching.
Thank you.
Micro is yours.
Thank you. Will I be able to? Okay. How do I go back?
You just tell me to go back.
Oh, okay.
But you can go from.
I can go forward. Okay. Okay. So my name is Franco Ligabue. I'm from Pisa, from Scuola Normale Superiore. I'm also a physicist, like a previous speaker. My field is particle physics, experimental particle physics. And I'm adjunct professor at Scuola Normale, so I do a lot of teaching. So I apologize for this sort of pompous title that I gave to the talk, but it's actually just a brief overview of the various kind of activities which are different than classroom frontal teaching, and are integrations to this process of teaching. And of course, they are limited to my experience, to what I'm been familiar with in my experience. So basically, this is master classes, which I've had the experience of a couple of times. Guided visits to laboratories such as CERN. These are not really new things, but I think that they're still important. Also, science popularization and science outreach activities, such as the European Researcher Night, or BRIGHT as it's called now. Sorry. And then, okay. Okay. You have to go back a little bit because I was still in the first. Okay, and then the okay. I also do some translation of popular books as a personal side activity, but I won't talk about that. And then I would like to focus on this on last part of the talk about this art and science project, which I think is something rather new and interesting. Now I see my back. So just as general considerations, I'm from, okay, as I said, Scuola Normale Superiore, which is an old institution in Pisa for very few selected students. And it used to be a very traditional institution, so with basically just frontal teaching. But in the recent years, they have tried to change something and introducing, for instance, the so-called third mission, which is outreach and dissemination and things like that to the general public and to high schools especially, and they have greatly boosted this. So, for instance, I will talk briefly about this La Normale a Scuola project, which was started during the pandemic, which is giving lectures, online lectures to the general public or to high schools. Again, this is not really something terribly original, but I think it's important. Okay. First thing, I first kind of experience I want to review is this Research at Night activity, which you probably already know of because it's something which is at European level and which is very successful and it's been done for a number of years now. And so both my institution, Scuola Normale, and INFN, of which I'm also part, takes part into this. And so once a year in September, this is done. And in Pisa, for instance, at INFN, what we do is to take people to visit the labs, and also we set up stands, public stands in the city center, for instance. Last year it was like that, where researchers and other people can present posters, and also they are available for the public to ask questions and answer, so present their activity to the general public. And this is, of course, good as an outreach activity for the public. Okay. Back and forth. Okay. For the general public, but also for undergraduate students, because they have the opportunity, as my colleague was saying before, well, nothing comparable to what he's doing, but they have the chance of seeing, even if they're first-year students in physics, for instance, and seeing what, for instance, particle physics is about, and for particle physics because it's my field, but of course other kind of research activities. They're getting to see it for real, in a way. And what I contributed to, for instance, last year was this virtual visits of CMS, which is the experiment I'm involved with at CERN, at LHC. And what we do in this kind of events is that the experiment provides these virtual visits to the public, and these were organized in Italian, so there were Italian researchers up there going down to in the experimental cavern and showing students and general public as well what the experiment is, showing them the details and showing what the activity is, and so it's a very interesting opportunity to look at what is done at CERN in this kind of experiments. The online lectures done by the Scuola Normale, this was something which was invented last year during the pandemic, because it was invented as a way of reacting to the situation of lockdowns and so on. And so they thought, what about so it is part of the third mission endeavor of the Scuola Normale, and they thought, what about giving lectures to the outside, to high school students? So the professors from the Scuola would find a subject which they thought it could be particularly interesting, or about their own research, or particularly interesting, and they would broadcast it. So not only for it was targeted at high schools, but of course anyone could join in. And so this was very successful. It was received enthusiastically, so it was repeated this year. And this, it's meant for high schools, but also because it's called La Normale da Te, La Normale a Scuola, means Scuola Normale at school, or in a school, or brought to you. And so, but also students, university students from other disciplines could attend, of course. And this, I think, it's also important because it encourages crosstalk, cross-feeds, and multidisciplinarity, which is always good, in my opinion. So this was my contribution, which is a talk, a lecture about the Higgs boson discovery and lottery draws and the similarities between two things. Masterclasses is another activity I've had experience of. These are very interesting. This is something which is organized by the ones that we're doing, is organized by CERN, so it's something very well organized. We didn't have to work a lot to prepare that because it was already built. And this is also targeted to high school students. What they do is to they last typically one day, and in the first part of the day, in the morning, the students are introduced to, of course, in a very simplified way to particle physics and to the CERN experiment, what they do, and then they are taught what to do in the following part of the session, which is an exercise with real data, and that's the interesting thing, because it's they actually use a simplified version of actual data. They're not simulated data; they're actual data from high energy experiments. And for instance, you see here. They are shown what we call event displays, which are taken from actual collisions of protons at the LHC, and those tracks that you see, the red ones, are actually particles coming out of the proton-proton collisions. But the guys, the students, are taught how to recognize the various particle types based on how they look on these screens, and using those to select some kind of decay. For instance, in this exercise, I had to recognize W particle decays from Z particle decays. It's something which sounds very difficult, but it's not, because once they learn the principle, they have to recognize which kind of particle they're, and they have to reproduce the yellow plot on the right in a way, which is a scientific, real histogram published on a scientific paper. They have to produce that, of course, not exactly that, but they're doing the same thing in principle. So what they do is to collect data, and then they produce histograms, and then they actually find out that they are producing histograms like that, and they are using real data to produce real results in a way. So they know, they learn, even if it's sort of a video game, they learn how things are done, and some basic statistics principles, or even they don't make any calculations, but okay, I think it's very, very useful. And one thing is that, one nice thing is that also classical studies students have participated to this, so that's important. These are the guided visits to CERN. Some of the pictures taken during the years, I'm among those guys. By the way, these are Squadron Normale students, and by the way, if you're wondering if we have a gender issue, yes, we have. They're basically all males, yes. So this was this tradition of visits to CERN was started a long time ago. In the late 80s at Pisa by a professor at the time who was taking students to Fermilab, Chicago, and the purpose of this was to recruit students for himself. So it had a specific purpose. But then the tradition went on, and it was revived some time ago, some 15 years ago, by Scuola Normale professors. And then we're doing this every year. Now that we stopped, unfortunately, for the pandemic, and we didn't do it for the last 2 years. But then, okay, I think this is also a very important thing, because all the students here of the Scuola, so not just physicists, but also mathematics students and biology students and chemistry students are taken to this visit, and they spend one day at CERN seeing all the facilities and a number of facilities and experiments, and they are shown this kind of life also that the physicists and also engineers at CERN lead. And so it's very important, both because they see the real thing, and because, of course, this kind of activities they are socially important as well, because of course they help creating bonds and so on, also between teachers and students. But then the last, I don't know how much time I've left. The last thing, which is I think the real new thing I would like to talk about, is this art and science project. This was something which was proposed, I think, 3 or 4 years ago. This year's edition is the third one. It was proposed by INFN, so the Institution of Particle Physics, Italian Institute of Particle Physics. And it's called Art and Science Across Italy, so it's an Italian-wide project. It's targeted at high schools. So it's for national high school students, and the idea is a contamination between two activities which are apparently very, very distant from one another, which are science and in particular particle physics and art. And what the students are asked to do is to try and find connections, and try and see beauty or the artistic or aesthetic aspect in physics. And this is also, in my view, also a two-way thing. It's also, you can also see how science can be used to make art, or see the scientific part in art projects and artworks and so on. I think the importance of this is that it really allows to view things from many different perspectives, and it's incredible once you actually look at what the students do. They have a lot of ideas. I mean, it's art ideas. They're not scientific ideas, but I think that prompting them for new ideas is always good, and it's always something that makes even organizers. They make us think, because there are some aspects, some perspectives that you had not considered. So I think it's always very useful. So this is a contest. So So I have to go back. No, okay. I don't know why it changes. So it's a contest. It's organized in local exhibitions at local INFN sites. So with local schools participating to that, and then they each local exhibition selects, with the jury, they select a number of winning artworks, which are then sent to the national exhibition. And the national one is currently open in Naples this week. So this year's edition is just finished, and the exhibition is open in Naples. In the first phase, this is organized in phases. In the first phase, the students are introduced in a sort of classical way to particle physics and so on, with seminars, talks, and things like that. But so this is the boring part. But also visits to museums, also visits to labs. So they're presented with the open problems of modern physics and so on, which is not obvious for high school students in the last year in the last years of the high school, but also they can be also presented with artworks in the first part. For instance, in the last edition in Pisa, we had this. We showed them, we brought them to see this theater play, Copenhagen 1941, which is based on the relationship between Bohr and Heisenberg at the time of the making of the atom bomb. So they were introduced to the physics of the atom bomb, of course, simplified and so on, and things like that. Then in the second phase, they are divided in groups, and groups of 2 or 3 students maximum, and each supervised by a teacher, and then they have to devise and elaborate on a project of an artwork, which is then submitted to a committee, which selects the worthy ones. And the selected and approved artworks are then actually made. So they're given something like 6 months time to actually build or paint or do whatever, and then the final works are exhibited at the local exhibition, and then judged by a jury, and then again, for instance, I think it's seven winners for each local exhibition. They're sent to the national ones. And then there's a national contest, and the winners of the national contests, the prize is a week. Okay, a week at CERN. I'm almost done. A week at CERN. So, where they sort of internship. They will live a week with among researchers. I'm almost over. This year's edition was very successful. This is the number of participating students, the number of high school, 158, 13 local exhibitions, and 27 prizes of weeks at CERN that were granted. I'm just showing rapidly some of the artworks in the Pisa exhibition. These I liked a lot. But by the way, the one on the left is one which was among the final winners in Naples. It's called Unbearable Lightness or Unbearable Heaviness of Matter or something like that. It's about the matter deforming space, the weight and the feather. This year's novelty was this Now It's Our Turn part, where the idea was that the adults as well had to participate. So the organizers, the researchers, and the professors, they also could participate, and they were judged by the students. So 12 artworks by researchers were selected. I think this is very interesting as well, because it forces you to, of course, if you want. I did participate with this. This is my contribution. It was a portrait of Richard Feynman, and it's a video actually, but I wasn't selected, unfortunately. I wasn't in the first 12 until the last minute, I'm told. But the interesting thing, and that's why I'm talking about this here, is that there's a proposal to extend this in the future. The idea is to make it European instead of just Italian. So, and I know that Greece and Spain have already agreed to this, and also extend it to university students. And so there are plans which are already on the way for the next edition to be international and to be open to student universities. And I know that there should be a poster about this made by the Madrid University. Have not seen it, but I'll look for it. So you're invited to look for it. Okay, so it would be nice to extend it to other universities as well. And this is basically everything I had to say. So sorry if I...
Thank you very much. I think posters are outside on this level, so please visit them. We had 50 minutes for Q&A, but we lost it at the beginning of the meeting. No, with the technical problems. But I think we have some time before lunch, so please share your thoughts, put your questions or comments to all of our speakers.
I want to ask.
Yes, please.
Verse. I can't pronounce it.
The Hungarian
yes.
speaker, András Vörös.
András Vörös. I want to ask you a question. So you said that bachelor students join your research group. I wonder, does the bachelors help the research group, or it's only beneficial for them?
Well, at least they just study, but you know, we are actually an educational institution, so it's I think it's natural that at first they have to learn, and if they are motivated, they can participate and they can do useful things. But I guess students become mature enough only during the master. So in that phase is when actually their work just reaches the technology readiness level. That is. Sorry. So they will just reach at the master phase the technology readiness level that is that can be used also by the department and the university, but it's not a problem. So at first you have to learn a lot. Actually, some years ago there was a high school student that just asked us to help him to learn new things, and we started to deal with him, and he just published at one of the most influential software engineering conference a paper at the end of the bachelor. So I think we have to support students early, and then I'm sure that most of the students will reach a situation level where they can really help in our research.
Thank you.
Next question.
Hi, thank you. My question is for all of the speakers, because I think it's really open broad. So where is the limit? I mean, where is the limit related with research or learning? And who imposed this limit? Okay. Yeah.
Please use the micro.
My experience is just the students does that, because you just give them and then show them the road, and then in my case, for instance, I also don't know what's after 1 kilometer. So if they decide to take the road somewhere else, they decide. If they want to keep on learning, they decide. If they want to do research, they can decide. Because if you want to keep the productivity of a young mind completely open, you cannot impose anything. You cannot set them. The only thing you can tell them is in the lab, okay, don't step on the cables, be careful, don't blow up the lab. That's the limit. I mean, that's my experience at least.
Yes. Your question is about the limit of what? The groups? No.
Who poses the limit between research and learning? It depends on the students, it depends on the teacher.
Yes.
In the case, it depends on the students. It's like to the infinity and beyond. Who knows?
Yes, I think that is related to the profile of the students, no? Because you know that the students that studies in master and doctoral programs, they will be more interested and need more the workload of research can be higher, no? but I think that is needed to study the profile of the students.
My opinion is that learning is limitless. So actually students can learn as much as they want and they can do as much research as they want. The only thing is that so in this whole framework that I just draw, these TRLs, is just because to motivate students in computer science, you have to show them an end application, that you will just do something new. And actually, if there is a goal of a project, then you cannot actually learn and learn and learn, but because you also have to produce results. So sometimes you have to decide, okay, now it's time to develop a prototype that it is, let's say, not necessarily as interesting as doing research, but it really needs so students need to do also this kind of stuff, especially if they are really motivated and they want to reach and produce something new. So this is an investment, and sometimes you have to invest in different parts of this process.
Yeah, I'm not sure. I'm not sure if you wanted to ask about the limiting, meaning the border between learning and research, or the limit, and also because people have answered you about the limit for single students, as far as I understood. How much can a single student do? Was that a question? Because of course, as my colleague said, research is unlimited by definition, sort of. And of course, what a single person can or will do is just a matter of personal conditions, tastes. So I'm not sure how to answer this.
You know, when you are developing any subject, you have some particular learning objectives to accomplish. So who poses the limit? Is the student to get these learning achievements, these learning goals, or is the professor interested in the research field to be developed by the students to produce a paper, for example? What is the level of the?
Maybe.
Actually, when I tell this, I'm going to really feel old, because you remember previously PhD didn't have a time limit. And this was 30, 40 years ago. Now everybody is pushing, especially European standards are pushing it to 3 years, 3.5 years, which I think it's stupid. But when I look at the really old PhD projects before 80s, some lasted 7 years, some lasted 10 years. There, I think you can see the limit there, because a student takes an interesting topic from the professor or the environment. They study for, at least that was the case in my PhD. So the first year, that was a project, yes, but I was given freedom. I think that's the Dutch way, I don't know. The first year I looked around. Nobody just pushed me in a certain direction. There was a project, yes, there were expectations, but there was still a fundamental research project. Then I figured out something. The really old ones were really giving the student or the researcher at the time an idea, then they just developed and they finished. So this, for instance, if it wants to end in a paper, automatically it is decided by the course of action that one takes. If it's just, I don't know, a product, if it's an engineering project, okay, there has to be a I don't know, some form of prototype, whatever. Yes, or something else. But I think the course, the nature of this research decides naturally itself the limit. But the limiting factor there is now time. So when I look at all the PhD projects, because we receive all these advertisements for students, yeah, we're looking for this PhD for 4-year limited term, whatever. There, I think there's an it's imposed by the European Union or the funding institutions because of the time and the money. But the real research, that's why I can give you one example from personal experience, not with the undergrads, but with the high school students. I had done several projects, but one of them was, I think this undergrads, not undergrad, but high school project contests, which is also popular now in Turkey. They are really bad examples of research. Because now, the university system, at least in Turkey, gives additional points or scores to their score, so they can make it better to a university. But now it's not fair anymore. Some rich schools can get more money from their families or whatever, so they get additional scores. Some underprivileged students don't get this. But then when you see, actually, they also, now there's the market for student projects that they can buy projects. What I did was, I was lucky because I started at the third year, because the high school is 4 years. They wanted something. Topic is not important. And then in the end, I told them, look, I'm not going to give this to you, but you can use all the facilities in the lab, and you can build your own, including. And they built, even high school students built a CVD reactor in my lab. They did it themselves in 2.5 years. And one of them chose to study physics afterwards. So I could see how they automatically limit themselves, actually, because in the end they see, okay, we do research. Research is fun. But they have to stop at some point, and then also they either train a colleague, a new student, they make a project, or they publish a paper, or they go to a conference, or they go to industry. This is a very, actually, this is beautiful self-limiting process. It's a stochastic process, actually, but beautifully self-limiting. That's my experience, but that requires numbers.
Okay, thank you. Any other questions, comments, remarks? If not, I would like to say thank you again for our speakers. And I finished the session. Enjoy your lunch. Thank you very much.